What's up, guys? How are you doing? I hope you're well. So this is a new project series that I'm starting. It's Golang and DynamoDB, and we'll be building a bulletproof CRUD API. Now you know that CRUD APIs are at the center of everything, right? So if you can build a CRUD API with a particular stack, you can probably build more complex products off from it. I've received a lot of requests recently. So people have said that, okay, MongoDB is great. You know, you've shown me MongoDB, you've shown me Postgres, you've shown me MySQL and SQLite as well. So, but what if I want to go serverless with the database? What if I want to take it to the cloud? What if I wanted to, scale automatically and be like for it to be a completely fully managed service? What if we're going into production? What if we're expecting millions of users? That's when DynamoDB comes in handy. It's completely serverless. You pay as you go. And it's the sky is the limit. I mean, even sky is not the limit. You can just keep scaling to millions and millions of users with DynamoDB, completely fully managed. All right. So that's what we'll be using here. DynamoDB is like the ultimate, in my opinion. It's no SQL. It's fully managed. It's on AWS cloud. It's serverless. I mean, what more can you want, right? So I'm really excited for this project. And the project structure that I'll be sharing with you in this video is going to be very different from what we have done till now. So in every series, I try to change the project structure entirely, and I try to experiment with new type of project structure so that we're able to kind of get a flavor of everything that's there in the market. All right. So this is going to be a very different project structure, and I'm going to be using the chi router. So some people might call it Kai or chi router, whatever you want to call it. This is just like a routing middleware. It's not a full blown framework. I think like people call it a framework, but I think it's just a middleware router kind of thing. And it's not like Gin and Gonic. It doesn't have all those features. It doesn't have that level of abstraction, but it's fun to work with. I mean, I like using it a lot, and I use it in a lot of projects. So I highly encourage you to use it as well, because there are some things that are very easy to use in the chi router. Firstly, it's very easy to set up, very fast. If you're working on a fast project and you want to get things done very quickly, it's very fast. And there's also more control. I mean, with Gin and Gonic, I feel there's so much abstraction that you're not able to really control so many different things. I mean, you're so dependent on that library, right? So I hate that. When I'm going into production, I want to be in control of the code. I don't know, maybe I'm just old school. I don't know, man. All right, so why do I call it bulletproof? It's because this project structure is going to be quite good. So we're going to have defined error messages for different type of errors, like let's say 200, 500 or 402 or 404 or 422 or whatever you want to call it. You'll have different error messages for all of those different scenarios, and then we'll have we'll be using interfaces. We'll be using a logger. We'll be handling course errors. We'll be having a health check to ensure the project is live. We'll be having a recovery middleware. We'll be using Chi for that. And then we'll have some validation. We'll be using a library called Ozo for validation. It's very easy. That's why I like to use it. Very simple, small libraries, right? So it's a really solid project structure, really solid CRUD API. You can use this project structure as is for your future projects. And I highly encourage you to use chi router. I highly encourage you to use DynamoDB because there's literally no limit for you to scale, right? So you need to know the concepts with Postgres, with MySQL, and with MongoDB. So all those concepts can be very handy when you work with things like DynamoDB, which are fully managed services. All right. Now you know that I don't like to waste a lot of time, so what I'll do is we'll get started right away. I've opened up my terminal and we'll start creating the project. I'm in a place where I usually keep my Golang projects, and we'll say mkdir DynamoDB Golang YouTube project. Actually, that'll be too long, so I'll just say CRUD, I think. And then YouTube, or just YT to save some time. I'm not sure if it saves any time. Anyhow, so we'll cd into it. So we'll say DynamoDB, and here we'll open up the code using our favorite code editor, which is VS Code. All right. So yes, I trust the author because the author is me. Now I'll have a folder called CMD. All right. So we just like building the project from a 10,000 feet perspective, right? So I want to have a folder called CMD. I want to have a folder called config. I want to have a folder called internal. And I want to have a folder called utils, which is basically your utility files, right? And yeah, that's about it actually. Now inside CMD, I'll have a folder called app. Okay, so by the way, like I said, I think I've already told you that this is a new project structure that I'm kind of trying out. I've seen it somewhere, and I want to like try it out. I've seen it in a Python Django project, right? So I want to try this out, and so I keep trying out so many different project structures because I want to know which one is the best, which one scales well. When you have a project structure, it does not mean that the technology scales well. It means that process-wise and people-wise, how does it scale? In the sense, yeah, if multiple people are working on a project, does it become easier in a particular project structure for them to work? Because I think it does. I think the project structure determines how easy it's going to be for many people to work together on a project, all right? And how easy it's going to be to scale in terms of features, in terms of the number of files that you put out. So I keep experimenting a lot. And you're welcome to experiment with me because, if you watch this channel, I am doing different things in different videos anyway, so keep experimenting with me. Don't stick to one approach that will really restrict your career completely, all right? You'll just become like a frog in a well, just if you know just how to use let's say just Node.js and Express.js, and I can only use Redis. That'll just really restrict you. Just work around with different type of frameworks, right? Instead of Express, use, I don't know, Happy, HAPI, or use Fastly, whatever. And all right, so here you have config, and then inside internal is where the most of the magic is, right? Inside of your internal folder. First, I'll just close these two files to keep things clean. Inside your internal, you'll have controllers. And inside your internal, you'll have one more folder called entities. Then you'll have handlers, routes. So routes will have your routes that will, the control will go forward to handlers, will go forward to controllers. That's how, I'm imagining it's going to work. And then you have something called as repository. So in the projects that I found that had this project structure, they in the repository that kept like models and that kind of stuff, and things to do with the database. So let's see what we use it for. Okay, and then I'll have one more folder called rules. In utils, you'll have environment, you'll have HTTP, and you'll have logger, because we're going to use the logger, right? Now, what you want to do is you want to create a very basic outline for the main.go file. If you've been watching my channel, I always do this. So it's a very, very basic kind of an outline. We'll have package main, we'll have import, and we'll have obviously func main, which is the most important function in any Golang project, right? And main.go is the most important file always. Now I'll have a couple of more functions, and I'll explain to you what they do, but just for now, write these functions. One is called migrate. Then you have a function that just checks your tables in the database. So just create check tables. Okay, and then just put this file on hold. I mean, we won't do anything here. So now what we'll do is we'll go to our routes folder, close this file for now, go to your routes folder, create two files here. So create config.go and create routes.go. routes.go. In your config.go file, now, so there's one more thing that we're going to do here, right? One thing I've probably not told you about is that each of the folders, all the files in those folders will belong to the same package, and that will make it very easy for us to import them into different files. So that means that inside the routes folder, config and routes, these two files will belong to the same package, and the package will be called as package routes. Okay, and at the same time, we can go to your routes file and just write package routes, and quickly create an outline here. You'll have your import, you'll have your functions for new router. It's new router, sorry. And just hold this routes file for now. Just write this much and just hold it for now, and we'll come back to it. But the most important part right now for us is to work on the config.go file. Okay, here you'll say import, and here I want to import three things. I want to import net/http, import time, and github.com/go/g/course. And I'll create a struct called config. Now this is something that I have not done before, so let me show you what I mean by this. And it has just one thing called time.duration. All right, so we've created a new struct called config. So we'll use it in our project, and we'll use it with the name of config. And it has just one thing called timeout. Okay. And here we'll have a function for our course, handling our course. The C has to be capital. And then we just have two more functions. We have one function which will be set timeout and get timeout. Now the reason we created this struct here is because all of these will be these struct methods. Okay, like methods, like basically struct methods are like functions that are applied only if you have that struct, right? You can read about struct methods more if you want. It's very simple. It's just like functions. They're just like functions only, but you know, you need to have this kind of a struct if you want to apply those functions. All right. And then we'll also have one more function called new config star config. So this just returns a config. Let me remove my headphones. Let me just check if this video is still recording, because I don't want to be in a position where, you know, I end up recording for like 30 minutes and then I find out that it's not recording. And config. Okay, so it just returns an empty config struct. This is what this function does. Okay, this is what it returns. All right. So for course, so I just told you that course, set timeout, and get timeout, these three are struct methods, right? What does that mean? C star config. And here you'll say next http.handler. So you'll pass the handler here in this function. And what you get back from this function? Again, handler. And then this function will have some definition. Similarly, here you'll again say C and config because it's a struct method. Inside set timeout, you'll say time in seconds and integer. So you'll pass a variable here, or a parameter here rather, called time in seconds. It's of type int, and this returns config. So just make sure the C is capital. And then you have your get timeout, which is again C star config. And here you'll have, so this function won't take anything, and it will return time.duration, which is basically c.timeout. Okay. So this function, get timeout, is just limited to this much. I mean, there's nothing more that you want to do here. But the set timeout function, we can do a little more. We'll say set timeout is equal to time dot duration, time in seconds, multiplied by time dot second. And you return config from here. Now the whole point of having this file is this function, actually, the course function. All right, and this is the most important function in this file. So let's create it. So we'll say return course dot new course dot options, And in these options, we'll define that from where all we want the origin to be, all right. So we'll say allowed origins string star. By saying star, that means we allow all origins. Okay. And what type of methods are allowed? So we'll say allow methods string star. We'll say allowed headers. So what type of headers are allowed? So I want to say that obviously everything is allowed in our project, right? So we'll say star. And exposed headers string star. Allowed credentials to true and max age to 5 comma dot handler next. All right, so next basically sends it to the next function, which is basically your HTTP handler. And so this is what basically your course function is doing. Very simple and straightforward. You're just saying that these are the allowed origins, these are the allowed methods, allowed headers, export header, all of that is equal to star. That means everything is allowed. I mean, don't give me an error if somebody else tries to access it from another, IP address or something like that. Anyhow, so this is this file is ready. Now head back over to your routes.go file, and here I want to have a struct called router, which will be config star config. It will also have router, which will be of chi whatever chi.mux. Okay. And so what does this new router return? It just returns, this function returns a router, right? That's why we have the function called new router. And that's why we'll say return a router from this function. So return ampersand router. When I say ampersand router, I'm referring to this struct. That's why I say ampersand router, okay? And so it has two values, config and router. So I want to define both of those. So I'll say here new config dot set timeout service config dot get config dot timeout comma router g dot new router. Then you'll have a function called set routers. So we'll say func set routers r star router. So this takes some parameters and returns the gmux. And then we'll have set config routers function. Important thing to note here is that set routers and set config routers, both of these functions are actually struct methods, right? So when we have a struct method of type router, that's how we have to write it. These are struct methods, and they take in some parameters. This function doesn't take any parameters, but this function does take some parameters. All right, so I'll talk about it in a while, not right now, otherwise it'll confuse you. And here we'll do a couple of things inside this function. Then we'll have a function for router health. So we'll say func router health. I'll have a function for router product. So all the routes that we'll be having will be around product. So like create product, get all products. All right. So we'll have router product here. And then we'll have a function for enable timeout. A function for enable course. A function for enable recovery. A function for enable request ID. And a function for enabling the real IP. So these are just outlines. We'll actually fill in these functions in the next video. We're just creating outlines for here. So you have your main.go file outline here. Config.go file is created. We've not written anything inside. And inside routes, we have our config. This file is complete. And routes, we've created the outline for many functions here. We've done a little bit of work with our routes.go file. Now in this video, just close off all these files and go to your repository folder. Create a new folder called adapter and create another one called instance. Okay, so now in instance, you want to create a new file called instance.go. And adapter, you want to create a new file called adapter.go. In instance, you'll just have some code related to connecting to DynamoDB with the right session. So let's say package instance. So as you remember, each folder, all the files inside each folder belong to that particular package. So this belongs to the folder called instance. So it'll be its own package, right? Then you'll import a couple of things. And the most important thing you want to do is you want to get connection. When you get connection, you get DynamoDB.DynamoDB. And you'll create a session. Say session. To be able to access session, you want to import two packages. One is github.com/aws/aws-go/aws/session, and the other is github.com/aws/aws-go/service/DynamoDB. Okay. And to create a new session, you get this function called must inside this session library. Right? It's a weird syntax, and the name of the function is also pretty weird. But I'm just referring to the documentation right now, and this is how you start a new session. So I'm just copying that and pasting that function as is, right? It's new session with options, and it requires a couple of things. It requires session.options, and which should be shared config state session.shared config enable. And what you do is you return from this function DynamoDB.new, and you return session, the sesh variable. This is what you return from here. So this is a function given to us by DynamoDB session library. Okay, this AWS session library, sorry. So not much to be understood here because this is their syntax, and this returns the DynamoDB client with the new session. All right, so this is all there is to this file. So this file for you is closed. All right, now adapter file belongs to the adapter package. So you'll say adapt package adapter. You'll import a couple of libraries, obviously, and you'll have so like I told you, repository folder. I told you in the last video that it's going to have mostly the code around talking to your database. So you, with instance file, you started your session with the database, you connected, and now you'll have some code around database. All right. So firstly, we'll create a struct called database, and this database struct is what we're going to use around to be able to talk to our database. And it has one thing called connection, which is DynamoDB, and it also has log mode, so it's booleans, true or false. Two packages that I know from the top of, like at the top of my mind, that I need right now is github.com/AWS/AWS SDK -go/AWS, and the other one I need is github.com/AWS-SDK-go/service/DynamoDB. And you will create an interface here. I won't use it right now, and I won't even create it right now. I'll just leave the outline to be here, and we'll come back to it in a while. A function that I need here is called new adapter, and it runs an interface. And this also I'll just leave it for now. Now there are now the other functions. These ones I'll talk about. These are like your what do you call it, basic hygiene kind of functions. But the most important functions that we need in this file are our find all function and our find one function. Basically, these functions directly talk to your DynamoDB and directly get the information that you need. So from your controllers, you're going to call these functions mostly. I've not planned it out yet, but mostly these are the functions that will be called, and these functions are basically your database level functions. All right. So you'll have find one here. Then you have your create or update, and then you have your delete. Okay, so these are the functions that are most important: find all, find one, create or update, and delete. Now there's one more function before this, which is the health function that we'll need. This returns a boolean, and in front of this function I'll just write func, and this is a method, struct method. So I'll say db star database. Database, we've already defined the struct, and this is a struct method. Now, as you can imagine, and as you can easily guess, all of these functions that are to do with the database, which are going to run queries on your database, are struct methods. Okay. So let's actually, so these three functions, right? Find one, create or update, and delete. These three are quite simple. So instead of delaying it and probably doing it in a later part video, I think I'll just do it right now. So for find one, now this is all DynamoDB kind of syntax, all right? So you may have to just get used to it. What you do here is you say DynamoDB dot get item input. So this is a function given to us by the DynamoDB library. Okay, and here you'll say table name. Just like in MongoDB you say collection name, from which collection you want something, here you say table name, and you pass the table name here, comma, you have a key, and here I'll write something like this, condition parsed. And we'll do something about condition parsed right now itself, right? But for now, all you need to understand is DynamoDB gives us a function called getItemInput. It requires two things, table name and key. Okay, and what you return from this function is db.connection.getItemInput. What's input? Input is this. So you'll say input Okay, so whatever is returned from this function, which is a database function, almost like a MongoDB function, you capture in this variable called input, and this is what you return from this function. Okay. Now talking about condition parsed. So condition parsed, comma error is equal to DynamoDB attribute. It's a DynamoDB attribute. So we'll say DynamoDB attribute dot Marshall map, and you'll pass a condition here. What's the condition? Where does it come from? We have no idea, right? So we have to put two brackets in front of, one bracket like open and close, which I call as two brackets in front of find one. And here to this function, the find function, we have to pass the condition. The condition is of type map, and it's string and interface. The other thing that we pass to this function is the table name, which we need here. I hope you're understanding. If you're not understanding, then definitely post it in the comments below. I'll come and help you out. All right. What we return from this function is just a response. So we'll say response, but it's of type DynamoDB dot get item output, or you can return an error also from here. So you already get the condition here, find one. The condition is basically like, let's say, what do you want to match? Do you want to match ID is equal to 1 2 3 4 5? What do you want to match? Name is equal to this. So find one, whenever you call the find one function, we're passing a condition. The condition can also be an empty bracket. So that means no condition is passed. That means get all the data. But since just find one, we get just find. So it just finds one data point matching that condition. Okay. And here we'll say if error, we'll check for error. If error not equal to nil, we'll return nil. We'll return nil for the response, and error is what we'll return here. Okay, so find one function was easy, right? Now we'll work on our create or update function, which is again quite easy. So the main, the crux of this function is here. So you'll have to say %, DynamoDB, just like this part. This is the crux of this function. So here first we'll write the crux, the core part of this function, which is put item input, and you'll pass the item. So you'll say entity parsed, comma, and you'll pass the table name. Table name same AWS dot string, comma, inside bracket is table name. What you return from this function is db dot connection. For connection, the C is small. Just make sure you do that. Put item and the bracket input. And what's input? You already know what's input. Input is basically what you get back from this database function. And so now we're wondering what exactly is this? What is entity parsed? Right? So entity parsed is DynamoDB attribute dot Marshall map entity. So what's entity? Entity is basically something that you will get in this function. So create two brackets. Entity is an interface. And the other thing that you get here is table name and string. Once we build the entity, you'll understand what the entity is, right? For now, just make sure you understand it's an interface that you're receiving into this function. What you send back from this function is a response. DynamoDB dot put item output, comma, error. It's an error again. Okay. Now, just like looking at this function, what we had done after that, we had handled the error. So let's handle the error. So we'll say if error not equal to nil, return nil, comma, error. So as you can see, these functions are really small and very easy to write. I'm sure you'll agree with me. For MongoDB, we have to do a lot of work usually. Same with MySQL, right? We have to do a lot of syntax writing. But with DynamoDB, it's getting pretty simple. There's not much here, like create or update function. It's quite simple, right? There are no different functions for create and update. There's just the same function, create or update. Isn't that amazing? And by the way, the documentation for DynamoDB is also very, very easy to understand, right? So here, so as you know, if you've used delete before in other programming languages, you know that delete is very similar to find one, because for delete, you have to find that one element that you're looking for using a condition, and then you have to delete it, right? So what does that mean? That means that I need to pass a condition here. So I'll say condition, right? And I already know it's a map of type string and interface. And obviously I have to pass the table name, which is almost like collection in your MongoDB, because you have to tell it which exact collection do you want to delete something from, right? And it sends back a response, which is type DynamoDB dot delete item output comma error, right? Sorry. And here, now we'll write the core of this function, right? That means this part. So for the code here, what do you want to do? You'll say DynamoDB dot delete item output, delete item input. I mean, there's going to be a key, which will be condition passed. You already know. There's going to be a table name, which will be AWS dot string and table name, comma. What do you return from here? You return db dot connection dot delete item input. What is input? Input is basically whatever you get back from this function. That's what you're capturing in a variable called input. And what do you want to do about condition passed? It's going to be the same as find one. So I can either copy and paste this, or I'll write it again, which I prefer writing it again, because if you are new to MongoDB, new to Golang, I recommend that you type it along with me, okay? And not copy and paste things, because you want to build muscle memory and you want to get it used to the syntax. If error is not equal to nil, then you return nil, comma, error. Okay, so our adapter file, we've done quite a bit, right? Only this little stuff is left. And even for health, I think I can actually complete it quickly. So for health, all you have to do is you have to say db dot connection dot list tables ampersand DynamoDB dot list tables input. So you'll basically list all the tables, right? If the tables are getting listed, that means your database is online, it's live, everything is working fine, and there's no need to worry. And so you'll return error is nil. All right. So I have to rush for a meeting, and this is why I'll continue the pending part in another video, in the next video. I hope you're enjoying this series. It's quite easy, straightforward, and we're doing quite a bit here, and it's a lot of new stuff is getting covered. So I hope you're enjoying. If you have any queries, do put them in the comments below. So in your utils folder in your environment, let's create a file called env.go. In your HTTP, you'll create a new file called response.go, And in your logger folder, you'll create a new file called logger.go. Okay. And in your environment.go file, what you'll do is, so you already know that every package, every folder, the file inside every folder, or all the files inside every folder will belong to the same package. So this is package env. This makes it easy for us to import those packages into other files, right? That's why I use this package kind of format. And we'll have a function called getEnvironment, which basically helps us to get all the environment variables, right? And there will be some default values, and returns a string. So right now, what environment are you on? So you'll say os.getEnvironment. You'll by using the OS package, and we'll process the environment, whatever has been passed here. We'll process that variable env. All right. And if environment is 0, like, or nothing is there, blank empty string, then you'll return the default value. All right. Otherwise, you'll return the environment. This is it. So this is the small little file that I wanted to create for the environment to help us get which environment we are on and all the environment variables. And now let's head over to our response file. All right. And before the response file, actually, let's tackle our logger file because that's simpler to make. Again, as you know, it'll be a single package because it's inside of the folder called logger. So this file will belong to a package called logger, and we'll import the log package. So as you can see here, we're making the project so modular, right? The logger and is a different folder, and all of this is inside utils, right? So we have an environment and a response file and a logger file. All of these are in different folders and different packages of their own, and they belong to the utils folder. So this makes our complete project very modular, very easy to find out where is what, and find the location of the files really easily. So we have two functions. For logging, we either panic, right, put out the panic errors, or we put out some information. Here we'll have the message that you want to print out, which will be string, and the error. And if error that we've received is not equal to nil, then you want to panic and say message, comma, error. And your info also will have message, which will be a string, and data, which will be an interface. And here you'll log out message, comma, data. Perfect. So now let's come to the response file, which is the most important file here. And this will be called the HTTP package. And here I need a couple of packages. I need to use the JSON package. I need to use the log package and the net/HTTP package. And now I want to define what type of response my file will, my project or my program will send. All right. So the response will be of type struct. It will have a status, which will be like 500, 200, that kind of status, right? The kind of status that you get back from the server. And here you'll put these backticks. You'll say JSON, and it's defined as status. And they will also be the result, which will be interface JSON and result. Okay. So now we want to work on our functions. So the first function that we have is the new response function. So we'll get response back from this, and it'll accept a couple of parameters that we have defined right now. And then we'll have a function which will be a struct method. So this is a struct method of type response, which we have defined the struct as response. And the function is called bytes. And returns a slice of bytes. Then we have a string function. Again, it's a struct method. If you don't know what struct methods are, do take a look. It's a very easy, straightforward kind of a concept. So you have byte here. Again, actually, sorry, I rewrote the same function again. So this, in this case, it'll be string, and you get back a string. So the main function in this file that you want to work on, which is again a struct method, will be a send response, and there will be w http dot response writer and r, which is http dot request. And now we'll define different functions for different type of statuses. So first we have status no content. Then we'll have, which is basically our 200 status, right? Then you have a bad request status, so you'll say func status bad request. Then you'll have your not found. This is 400. You'll have func status not found and 405. What we're defining here is we're defining all types of responses that our program can send out, and we're standardizing all of that, right? So this is a really great practice. If you want to follow it in production, it's a really great practice. You're just standardizing all the type of what do you call it? This is the response that your program sends out. So func status method not allowed. Otherwise, your backend will just keep giving 500 server error, which doesn't serve a lot of purpose, right? Because we don't actually come to know what's happening inside the program, and we're not able to find the issue and error quickly. And let's create these curly braces because we'll be creating some type of definition inside these functions. Then you have a 409, which is status conflict, and you have a 500 error, your standard error, status internal server error. All right, so we have created the outline of this file. We'll be working on our routes file. So head over to your routes folder, open up your routes file, and here in the import section, we'll import github.com/go/chi. We need the CHI middleware to create those routes that we want to create. And here we'll also import the middleware. We also need server config, which is basically our config folder. And we'll need our health handler and our product handler. And we'll also need our adapter folder. But for now, let's just define these. All right. So server config for here, we'll say github.com/akhil/DynamoDB go CRUD YT/config, which is the config folder, right? And for our health handler, we'll say github.com/akhil/go. Sorry, I'll just copy this quickly. And we'll say internal handlers/health, right? Internal, inside that is handlers folder, inside that will be a health package that we'll create. And for product, we'll just copy and paste this whole thing quickly. And here, you'll just say product. Okay. So let's firstly set our routers. So how do you set your routers? You'll say r.set configs routers, which is basically calling this function right here. And you'll also set your router health and your router product. which are again out here itself. So we're just calling these two functions in this function, right, in the setRouters function. And in both of these, we're going to pass repository. And that means the setRouters function will take something called as repository, and this will be defined in adapter.interface. So we'll create something called as adapter, and then we'll also create an interface. But for now, we don't have it. But we're just assuming that we're receiving something called as a repository that we are passing into our router health and router product. And what we're returning from here is the router. Okay. Now let's set up our setconfig router function. Here we want to enable cores. We have defined all these functions. We have not written the insides of these functions, but we have defined them, right? And enable logger. Then we have enable timeout and enable recover. Enable request ID. Sorry, we should have written R here. And enable real IP. And now your router health function will be of type, which will be a struct method, and it'll have R and router. It'll accept again repository, something called as repository. I know we have not created it, and all of our functions are using it, but in the next video we'll definitely create it, right? Right now we're just assuming that we're getting something called as repository. So here you'll access your health handler, and you'll have a function called new handler in that file, which we're accessing here, and again we're passing repository to it. Now we'll start creating our routes. The first route you have is health. And in that health route, we'll have a function which takes in route, which is of type grouter, and we'll define that function. So we'll have our post method, we'll have a get method, we'll have a put method. Sorry. Have a put method, we'll have a delete method, and we'll have an options method. And similarly with router product, it'll be again a struct method, and it'll accept repository, which is again of type adapter.interface. And again we'll write handler, product handler dot new handler, NS capital, sorry. Oops. Just make sure this N is capital, right? And here you'll pass repository again. And just like your router health, you'll again have this type of a format where you'll define all APIs or routes with /product. Okay, and here we'll define the function where again we'll have our post route, we'll have a get route, we'll have a put route, we'll have a delete route, and we'll have options. So let me start with this, and then we'll do the same process in router product. Here the first so after health we want to put a slash, right, and we want to handle all the post operations using handler.post function. Okay, so at the health route /health route, at the root of the health route, we want to handle the get, post, and all these methods. And the get, I want to handle using the get function, handler.get function. And here I'll have the handler.put function. In delete, I'll have the handler.delete function. And in options, I'll have the handler.options function. Similarly, in our product route, we'll have slash handler.post. We'll have slash handler.get and slash. Products will have IDs, so we'll have to pass an ID to update a particular product. So we'll say handler.put. Similarly, we want to delete a specific product, so we'll pass the ID of that product. Handler.delete. And here we'll have a slash handler.options. Perfect. So here I think we have missed one function, which is enable logger. So I'll create that function, enable logger. This too returns a router. All right. So in your enable router, what you want to do is you want to say r.router.use, and you want to use your middleware.logger basically. So your chi router gives you a logger, and that's what you want to use in your enable logger function. And you want to return r, the router. All right. Enable timeout. For enable router logger, what you want to do is you want to say r and router, because this is a struct method again. It doesn't take in anything, but it's a struct method nevertheless. All right. And here again you want to say r star router, and your enable timeout function again returns a router. Your enable cores returns a router, and it's again a struct method. Enable recover also as a struct method, and returns router. Enable request ID also a similar setup. And enable real IP, same as well. It's a struct method that returns a router. And the inner definitions of these functions will also be very similar. So here you're using the logger, and in enable timeout you'll use r.router.use middleware.timeout function, in which you'll pass r.config.getTimeout function. In enable cores also you'll use r.router.use r.config.cores, and you'll return r. In enable recover you'll say r.router.use middleware.recoverer. Enables request ID, you'll say r.router.use middleware.request ID. And from both of these functions we are supposed to return r. So firstly, the spelling of return r is wrong here. Here also you'll return r, return r, return r from this function as well. From here also you'll return r, and here you'll say r.router.use middleware.real IP and return r. And the response.go, you will say for new response, you will pass it data which has interface and status is int. And what you want to return here is response and result. So just to explain to you, response is the struct that we have defined, and this is the type of response in this format that we'll be sending from this program always. To create a new response, we'll have to call this new response function, which will take in some data, and I'll take a status. Like status is basically int, like 200, 500, and those we have already defined here, 200, 400, 404, right? We'll define all these here. So whenever you're turning a response from this new response function, you will have a status and a result, again, which is of the type struct, which is compliant with our struct that we have defined. So for the status, the value is status that we have received here, and for the result, the data is an interface, the data that's passed here, and we create the whole response, which is of the struct type, and it's sent back from this new response function. So whenever you want to send response from this entire program, you're basically using the new response function to send it, right? And this basically function returns a response. Makes sense? And here, what we'll say is first we'll work on our send response function. Okay, so send response function, you'll say header dot set content dash type. So right now all that we're doing is we're laying the foundation for our entire project. So we are creating the routes, we're creating the config, we're creating the response, all the utilities like response, environment, logger, all of these different things. And now we're just creating how the response is sent to the front end. So you set your content type, you set your access control, allow origin kind of things to handle the coarse errors. And then you'll write header, which will be basically the status. And you'll send response.bytes. So two values are received from this function, and we'll mark both of them as blank characters because we won't use them. And what you want to print out is response.string. Now response.status, response.bytes, and response.string are, so bytes and string are these two functions, right? So whenever you want to access a struct method, right? So this is a struct method, this is a struct, these are the two struct methods for that struct. And whenever you want to use a struct method, you use it like this, response.status, because response is the struct that we're creating for that struct method. Okay, so that's how you use it, response.bytes, response.string. So these two are the functions. And what do these two functions do? Not much, they just marshal it. So they say marshal the data, so you'll marshal the response here, and you'll get that in a variable called data, and this function just returns data, and string just returns whatever it received and converted to string. Okay, and now we'll just define all the status errors. So, sorry, status no content is going to be 204, and we'll have status OK, which will be, sorry, S is capital and the rest is small, and OK is again large caps. Okay, now we'll start defining all these functions. Try and finish all our the complete response file, and also the adapter.go file, which is inside adapter folder, inside repository folder, inside internal. Okay, so internal, inside that is repository, inside that is adapter, and we have adapter.go file. We'll complete that file, and also our response.go file. We'll complete it right now quickly. All right, now the status OK function, which returns the status OK when everything has gone well, basically a status of 200, accepts W, which is HTTP dot response writer, and accepts R, which is HTTP dot request, accepts data as well, which is type interface. Fix the spelling of data. And all of these functions now will call the new response function. So I'm calling the new response function here. I'll pass data. As you can see, the new response function takes data, right? So now everything will start making sense to you. And here we'll send status OK dot send response w comma r. So we're using both the new response. We'll create the new response and then we'll send the response like this. All right. Similarly, so we've used basically both our new response and send response functions, okay, to create a new response and then send it. All right. Similarly here as well, when we have no content, we'll say w http dot response writer comma r request http dot request and data, which is of type interface. Actually, since there's no content, we have to send status no content. That means there will be no data, right? So it won't accept any data. And then you have new response, which will send for data. Instead of data, we'll send nil. And we'll send http dot status no content dot send response w comma r. Then we'll send status bad request, which will be w http dot response writer comma r star http dot request comma error, which is of type error. Okay, so in the bad request, you'll send to get data, you're saying map string interface, and inside that we'll define the error. And in the new response, we'll send the data and http dot status bad request dot send response w comma r. Now for 404 status not found, again we'll pass w dot response writer comma r star http dot request comma error. Again we'll use the same data, which is map string sorry yeah, so I was going right, string and then interface error err dot error. And we'll call the new response function again, pass data to it, http dot status not found dot send response w comma r. Similarly for 405, again 405 takes these two things, so I'll just copy and just paste these two things. Okay, and here you'll say new response. For data you'll pass nil because this method is not allowed, so you don't have to process any data. So you'll say status method not allowed dot send response w comma r. And here you'll take these three things, put them here, status conflict, and for status conflict you'll copy and paste this data line, and in the new response you'll just copy and paste this, paste it here. For 500, this whole thing will be the same. And this will accept again these three things. Awesome. So our response.go file is complete. Now coming to the adapter file. you have to first create the interface. This interface basically will have all of these functions like health and find one, find all. So let's create that. So we'll say health, returns a boolean. Then you have find all. It accepts some parameters, it returns some. What does it return? It returns response of type DynamoDB dot scan output, comma, header. And what does it accept? You can see here, find all function. Okay, I've not defined what it accepts, but I can write it here. It's going to accept a condition. For find all, mostly the condition, as you know, we send an empty expression there, but still we have to send something. So I'll say condition, expression, comma, table name, which is equal to string. So this is your find all. Then you have your find one. Then you have your create or update, and then you have your delete function. So for find one, it's going to accept condition again, which will be like represented like this: map string interface, comma, table name string. And here what you're going to return is response, which is of type DynamoDB dot get item output, comma, error. For create or update, you'll accept an entity type interface, and you'll accept the table name, and you'll return a response, which will be of type DynamoDB dot put item output, comma, error. And then you have delete, which again accepts a condition. It's of type map, which has string and interface, comma, table name, which is a string, and response, which is type star DynamoDB dot delete item output, comma, error. So we've defined our interface, which basically is a list of all these functions that we have down here. And the important function, the new adapter function, is what we need to work on right now. It accepts connection, which is of type DynamoDB dot DynamoDB, and it returns an interface, right? So you'll return ampersand database, and for connection you'll say con, comma, log mode false. Then you're left with your find all function. So in the find all function, we've already defined what all it accepts and what all it returns. So we'll go to find all function quickly, say condition. It accepts condition, which is of type expression dot expression, comma, table name, and string. So in case you're wondering where this expression comes in, it's basically a part of the DynamoDB package. And just to be more sure, we'll say github.com/aws/aws-sdk-go /dynamodb/dynamodb attribute, and we'll import aws/aws-sdk-go/ DynamoDB/expression. Okay. So in our find all, here we'll return response star DynamoDB dot scan output, comma, error. And inside that, you'll create an input which will be of type DynamoDB dot scan input. And here in the condition, you'll receive a few things. So you'll have to assign it to some values that basically will be used by DynamoDB to process the information and find from the database, right? So we'll send some condition. We'll send some names in the condition. So that's what we are looking for. We're looking for some values in the condition that is being sent to this function. There will be some filters as well, and there could be some projections. So we'll say projection. And then there will obviously be table name, which will be aws.string table name. And here you'll say expression attribute names. Fix the spelling of expression attribute names. So DynamoDB requires this from you, expression attribute names, and the condition you'll receive in this function, which will have names, you'll pass it here. And the other thing that DynamoDB requires from you is expression attribute values, and you need filter expression and projection expression. So the things on the left are the things that DynamoDB needs, and things on the right are what this function will receive inside the condition variable. All right, so our adapter file is now fully complete, and adapter basically has the functions that talk directly to the DynamoDB. Even if the syntax sounds really weird to you, you read DynamoDB documentation, you'll understand what this is. So all we're doing here is basically we're checking the health. We're basically using the find all functions, find one function, create or update and delete. The basic CRUD, right? This is just the basic CRUD, and these are all the functions that talk directly to DynamoDB. And the response has been defined by us here. We have defined how to get the environment. We have defined how to set up the logging. We have in our config we have set up our cores, and in the routes we have set up all the routes, right? Like all the health related routes and all the product related routes. And then we've also created functions like enable logger, timeout, cores, right? All the basic building blocks of the entire project. So I hope everything is making sense to you now. Now we have kind of been able to set up the basic building blocks, and now we can start working on our controllers in a while. We'll also work on our handlers in a while. All right. So when I started building this project, right, the DynamoDB project, I realized that, oh, there's more that we can do with serverless, right? We can do lambdas, we can do API gateway. So I started creating those series also, right? So that's why I was away, and that will help you a lot in actual real world projects. Once you're very comfortable with DynamoDB, you don't have to use Golang servers, right? You can use Lambda that is completely serverless with DynamoDB, right? That'll be amazing for you. So complete the series, watch those other videos, and all of that, use all of that together, and you'll have like really good code to start building off other projects completely serverless. All right. So now we were done with our routes or routes, as whatever you want to call them. So we were done with our routes, right? And we want to now start. Eventually, we want to start working on our handlers, because as you can see, all the routes are calling get, post, and put and delete, all these functions, but these functions are in our handlers. So which is this folder here called handlers, right? And we have not started working on that. Now, and once you start building those handler functions, then you will be calling controller functions, and then the controllers will actually be calling your repository functions, which are your adapters, right? Which we have already built. So again, I'll just take you through it. We'll have routes. Routes will call functions in our handlers. Handlers will call functions in our controllers. And controllers will call our adapter or repository functions, which are our database functions. Now, before I start working with handlers and controllers, I want to first finish off my config.go file and main.go file, because these are like these are kind of important files, and I've not touched on them. And usually, if you follow my videos along, I always complete the main.go file first, and then I work on the other files. But this time, I just took a different approach. I showed you that I'm going in a more logical manner, in the sense you'll have your database functions, and then you'll have your routes, and then you'll have everything in between that we'll build now, controllers and handlers and controllers that we'll build now. But then there's also the main.go file where the program actually enters from, right? So that we've completely ignored. but I want to work on that. And to work on the main.go file, we want to have a config file because we obviously want those environment variables, right? So I'll call this package config. Now, a lot of questions that I get usually is people asking me, why do you create these different folders and have the same file name inside that folder? So this is a Golang pattern. It's a project structure pattern where the file name has to be the same as the folder name, and all different packages are in different folders. So this is like I think from Golang 1.15 they've done this, where this name has to be exactly the same as the folder name, right? You can't even have like C capital or G capital or something like that. It has to be exactly the same string matching with the folder name, and that's what the name of the package should also be inside your file, right? And then only everything will work perfectly. Otherwise, you can expect some errors. Sometimes people say that, oh, I didn't get an error this time, but somehow it worked. I don't know how, but usually you'll get an error. All right. So string convert is the package that I need here, and I need my environment variables. So how do I call it? How do I call my environment variables? So this is the name of my entire project, and I'll just copy and paste this there for the time being. So back in my config file, I'll just copy and paste this here. Now I'll just change a couple of things around. So what do I change around? I will say that in my utils, right? So instead of internal handlers, I want the program to go to my utils, which is my utils folder out here. And I want it to go to my environment folder because that's where it'll find my environment package, which has all my environment variables. And I'll create a struct called config. It's going to have a port. You always need a port for the servers to interact with, right? So which will be an int. I'll need a timeout because if the program doesn't work for a particular time, I want it to time out and let me know that there's an issue. Otherwise, it'll just keep showing pending. By the way, if you build production level projects and you don't keep timeouts, it can be a big problem because your programs will go completely in like a forever waiting loop. Like your front end will always keep waiting for your backend to respond or something like that, right? So just make sure you always do this. You always have a timeout for all your APIs or your backend server to get back to you. You'll have a database URI, obviously, because Golang needs to know where exactly to hit, right? Where exactly the database resides, which port to hit for the database. And now we'll have a function called getConfig, which will help us to get all these variables and define all these variables for us, right? So so that means wherever we are in our program, like let's say in our controllers or handlers or our adapter, we will call this config file and we'll get all these different ports and whatever, right? So, and they'll all call this function called getConfig. So for getConfig, getConfig returns config. Config is the struct that we just defined. So the getConfig function returns this complete config structure, right? And so we'll say return config, like I just said, it returns a config. Config has, as you already know, we've defined the struct here. It has these 4 different things. So it'll have port, it'll have timeout, it'll have dialect. Dialect is like, is it going to be like SQL and all that? And you have database URI. For port, I'll call a function called parse environment to integer. And we'll create this function right now in just a while. So I'll keep this port as 8080. And many times when this program doesn't work, right, I get a lot of comments on my YouTube saying that this program is not working on my computer and there's an issue. Please check if your port, whichever port you're using out here, is not already in use on your machine. So I think if 8080, if you're using, mostly Java also uses the same port most of the time. So it could be that some Java program is running in your background and that port is not free, right? So just change the port, come here and change the port or kill that process completely. Like on Ubuntu, it's very easy to kill it. I think it's kill -9, something like that, right? It's very easy, but I'm not sure how to do it for Windows. So if you're on Windows, you'll have to find out how to kill your ports or processes on those ports. Okay. For timeout, so we'll get timeout also. Just a second. Where was I? Yeah, on the config. Yeah. So timeout is 30, and dialect. So it'll be environment dot get environment, as in which environment is it? Like, is it prod or is it QA? You can define as many environments as you want. And dialect in this case will be SQL Lite 3. And then you have your database URI, which will be environment dot get environment and database underscore URI, comma. And then if you've seen the DynamoDB URIs, you'll see that there's this kind of a link that starts with memory, right? So these are the variables that I need. I need port 8080, timeout to be 30. I think this is seconds. And then you have dialect SQL Lite 3. This is the language that your DynamoDB and your Golang interact in. And then you have your database URL. This is where your database URL starts with, right? And then you have to create this function called, let me just create some proper spacing so that everything looks better. So you will have to create this function called parse end to environment. So let's create that function. What does it take? It takes an environment name. And it has some default values, which are string. These are the default values, right? And it returns an integer. Now we'll call our string convert function that I've just imported here but never used. String convert dot ATOI. If you have not checked out this package ever, string convert, do check it out. There are these functions like A2I that helps you do a lot of string conversions into integers and all those things. Just check them out. And it's basically basic Golang, very basic Golang. If you take the Golang tour, this is probably the first thing that it'll cover. Golang tour is a website where you can go and just learn the basics of Golang in case you didn't know. So just check it out. So here I'll get that integer in this variable called number, then that's what I'll return mostly. But if there's an error, I want to do something about the error also, so which will be basically error is not equal to nil. And I'll at that point for this integer I'll just return 0. Otherwise I'll return the number. All right. So if you want the port, it'll send you 8080. If you want timeout, it'll send you 30. That's what it's sending, right? The integer it's sending from here. And so this config.go file is done. Environment.go file was already done. Your adapters and your responses are perfectly sorted out. Now, like I said, we want to start working on our main.go file before I switch on to our handlers and controllers. So main.go file, you have package main, and then you'll import a couple of things. You'll say you want fmt, and you want github.com/aws/aws sdk-go /service and /DynamoDB. All right. And there are a couple of more packages that I need, right? So this is one package that I need. In case you haven't watched my serverless videos, I talk about this package a lot, right? So this is AWS SDK Go is a package for which I have documentation open on my other screen. I always recommend you have you go through this documentation because it gives you so many different things, right? The AWS SDK Go package gives you access to DynamoDB and so many different services like Lambda and many more services basically. So just check out this package, check out all the packages that I'm using. DynamoDB is a small package and part of this huge library that AWS gives us for specifically for Golang. And now I want to start getting my other packages. I think I'll put them here, like log and like net/http. If you can hear some background noise, please, what do you call it? Please ignore it because there's some work going on in my house, as always, because it's a weekend, right? So I have some cleaning stuff out here. Anyhow. Now I want to start importing my repository and instance, all those things. So I'm just wondering whether I should do it right now or I should do it later on. I think I'll just do it right now. Okay, so I'll go to my routes file and I'll just copy one of these little packages, right? Put it here. And here, what you want is inside internal, you want repository/adapter, which is this, right? Inside your repository folder, you have adapter package. That's what you needed. Similarly, you need the instance package. So you'll write the whole thing again. You'll just copy and paste it here. And here you'll say instance. Make sense? And then you need routes also. So for the routes, what are you going to do? You'll just copy and paste it here till internal. And just say /routes because routes is a separate folder, right? It's not inside the repository folder, it's a separate folder, so we'll say /routes. And then there's another folder called rules, right? I've not done anything there yet, but I would need it, so I'll just keep it here. And inside inside rules, there'll be another, sorry, it's called rules folder. Inside rules folder, there'll be another folder called product, which will be like rules specifically for product. So I'll have /product. Cool. And then you also need the logger package. So I'll copy this and paste it here, but I don't want internal, I want utils, which is a separate folder than internal, right? So they're the same level, utils and internal. So inside utils, I have my logger. So I need my logger here. Perfect. So let's start with the config, with the main file. So the main function I meant. In the main file, you have the main function. There's a variable called configs that we're creating right now. What does it do? It just takes your config and you get get.config. So now if you were wondering till now, why did I create the get.config function here in my config file, in my config package? Sorry, where's my config? Yeah, this one, my config package. Why did I create the get.config file? It's because here I was going to use it. So that's why I had to create it first. That's why I created my config file first, and then I'm now creating my main file. So this makes sense. Okay. Now I'll take a variable called connection, and this will be equal to instance dot get connection. So, and what is this, right? What is instance and what is connection? Instance is basically the file that you created along with me, which is inside your repository. You have instance, right? This file, and this has a function already called get connection, which helps you to set up a session with DynamoDB, with AWS and DynamoDB. All right. So that's what this function does. Now to create the repository, I'll take another variable called repository adapter dot new adapter, and you're going to pass connection in it. So now if you go to adapter, the file, you've already created this file, right? And there's a function called new adapter, this one. It basically returns the entire database to you, right? Along with the connection and log mode and all those different things. So the entire database you can access using repository. Make sense? Now I want to say logger.info. This is my logger package, and we'll say waiting for the service to start. Blah blah blah. Sorry. Dot comma nil. And you'll call a function called migrate. That is here. We want to work on this function. This is basically, I'm just going to write some basic code for database migration. Okay. In case you're not aware about database migration, just read a little bit about it, what it is and how it's done. So there's nothing fancy. You can completely skip it. Now that you've written errors equal to migrate connection, you will get a couple of errors. And to handle multiple errors, this is what we do. We say errors, right? Length is greater than 0. Then you do something. So we'll range over all those errors. And we want to obviously notify the user or the developer about all the errors, the developer in this case being us. So we'll range over them. We'll say error is equal to range of errors. And we want to panic in our logger. And we'll say error on migration, blah, 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 and comma, and we'll paste out the error. Perfect. And then you'll say logger.panic. You want to check tables, and if just check tables function fails, you also again want to panic using the logger. So check tables is a function that we need to create, right? I've already written it out. We will be creating this function soon. This just checks if there are the tables that we want to work with exist or not. Otherwise, we'll just create an error, right? So basic simple code for migration. We'll write these two functions, and for checking tables, basic code, right? This is like standard procedure. Whenever you're creating any file, any project that works with the database, it's recommended to use some migrating seeds and migrating scripts and all that, so that you're able to migrate the database. And also you're able to check the readable tables that they exist before you start working with the whole project. Otherwise, you will see some not so great results, in the sense inconsistent results is what you'll get. Okay, so fmt.sprintf and %v, comma, you want to print out the port. So you'll say configs.port. So you want to, format the string, and you want to take the port here in this variable called port. And similarly with router. So sprintf basically helps you to format a string, right? I know by mistake I had said printout because I thought I'm writing printf, whereas I was writing sprintf. So I just got confused. Anyhow, so the router, where do you get the router from? So you'll say routes dot new router. Now in your routes folder, you already have a new router folder function. That's what you're calling here. So you'll say new router, comma, dot set routers, and you're sending repository. And then you'll say logger.info. Service is running on port, comma, port. And we'll have our server http dot listen and serve. Now this you already know, right? To create a server in your Golang, you just need to write this one little line, which basically is a function that net/http package gives you with. It's called listen and serve. And all you have to do is pass the port and the router. And if anything goes well, you'll log out the error. So with migrate function, what you get is a connection to your database. So you'll say DynamoDB.DynamoDB. Sorry, this is capital D, capital DB. And it sends back a slice of errors. So where do you see those errors? Errors is equal to migrate, right? And you're sending the connection, DynamoDB connection. And what's returning is a lot of errors, right? A slice of errors. And that's why you were doing the whole for loop thing. So firstly, to be able to return a slice of errors, you'll have to define a variable called errors, which is basically a slice of type error. Okay. And then you will call this function called called migrate and append error. So this is another new function, and we'll have to create this function. So we'll say call migrate and append error, and it basically takes errors. So here also you're passing to it errors, comma, you'll pass connection to it, and you'll pass rules product, which we have not talked about yet, and rules. We'll pass this. So we have not talked about this file yet, right? The rules and rules product thing. Don't worry about it for now. Just know that we're calling this function for migrating, and it's just returning errors in case things don't work out. So that was a lot, I think. We're creating our call migrate and append errors function. It's supposed to take errors, which is a slice and a pointer to error, and slice of errors, right? And then you'll have DynamoDB dot DynamoDB and comma rule, which we'll define in our rules.interface. So in case you're still worrying about this rules file, we have not created the rules file yet. The package we have not created yet. We already know what our connection is. We already know that the errors that we're sending, because that's what we're doing here. And rules is the only thing that I told you in the last video also not to worry about, because we'll work on this file soon and then everything will make sense, right? So here you'll say error is equal to rule dot migrate, and you'll send connection again. If error not equal to nil, we'll handle the error, this error that we just might get here. We're handling it. So star error is equal to append star errors comma error. So check tables, right? Check tables is a function we're calling up there, and we want to now start creating that function. It basically takes a connection to DynamoDB. So we'll say DynamoDB dot DynamoDB returns an error only if anything goes wrong. So we'll say connection.list tables. So connection, as you know, in this case is instance.get connection, right? And this will basically list the number of all the tables that you have in your DynamoDB. And that basically helps us to, that basically helps us with this check tables function, because we're checking if those tables actually exist or not. So you'll say list tables. Inside that bracket, you'll say ampersand DynamoDB dot list tables input. And whatever you get from here, you'll capture in something called as response, or you'll get an error. So if response is not equal to nil, you'll say if length of response dot table names. So from your DynamoDB, you've received the list of all the tables that are there in your DynamoDB, and now you're checking for your for their length of table names. If there's a 0, then you'll say logger dot info the tables were not found, comma nil. Otherwise, what you'll do is you'll loop over them. So you'll say for comma table name response dot table names and logger dot info table found, comma star table name, and you'll return the error. Right, so either table found or table not found. So obviously, right, once you get the list of all the tables, if the table names is equal to 0, then table is not found. But if you found something and you'll range over them, you'll print out all the tables that you have found, right? That's what this is doing. So this function is quite simple and straightforward. I think the only issue that you'll be facing would be here, because migrate is straightforward, but it's calling a function called call migrate and appender, and this is doing some things to do with rules which you don't know yet, and I completely understand because we'll be working on it, so everything will make sense. But our main.go file, I just want to tell you that our main.go file and our config files are both now complete. So we have done quite a bit, right? So just collapse these and collapse your utils also completely, your routes also. And I want to start working on our handlers now. So now you want to start working with handlers. You want to create 2 folders. One is going to be called health. Then you want to create one file called interface.go, and you want to create a folder called product. All right. Now in your health, you want to create a file called health.go. In your product, you want to create a file called product.go. And with the interface, you'll define a basic interface right now. So we want to quickly finish our interface. It belongs to package handlers because that's what the name of the folder is. Import net/http. Now, in case you don't know what interfaces are, I suggest you to go check out the Golang tour so that you understand what it is. It's a very simple concept that is also used in many other programming languages. So here we're creating a variable called interface of type interface, and we're going to define the interfaces for get, post, put, delete, and options. And all of them are going to look very similar. They're going to have a response writer, which will be type http.response writer, which basically gives you the response, and it'll have a request /http.request. All right, and you just copy and paste this everywhere, and that is it. That's your interface. Now I'm just checking if the spelling is correct here. I've not made any spelling mistakes or anything like that, because I've copied it in 4 other places, so it can lead to an issue. All right, everything looks good to me. And we can start working on our health and our product file. So in your health file, you'll call it package health, because it belongs to the health folder. The health file belongs to the health folder, so you can call it package health. And here you'll import errors, and you need net/http. Okay. And I'll need a couple more packages, and I'll call them mostly like from my own project, some internal things that I'll need, but I'll call them in a while. For now, just create a handler which is of type struct, and it will have something called as handlers.interface, and it will have a repository which will be adapter.interface. Now this obviously means that I need to import my handlers and my adapter, these 2 packages. And how do I do that? So let me just go to my main file and copy these adapter, at least the adapter I'll copy. I'll put it here. And I also need the, like I said, the handlers. So I'll just copy this much till internal. Inside my internal is my handlers. So I'll say /handlers. Right, so I need these 2, and I've imported these 2. Now let me define, like in an outline, all the functions that I need. So I'll need a new handler function, and I'll need a get function here. I'll need a put function, so I'll say func put, and also need post, and delete and options. So I'll need func delete and func options. Awesome. And now we'll start working on all these functions. So before I work on those functions, I'm just making sure if it's clear to you already that this handlers.interface, when we write handlers.interface, we're talking about handlers.interface. This interface is what we're talking about, right? And now I've just found this little issue here. Should have been CRUD, and I see this issue everywhere now. I think I'll have to just fix it quickly. So I just had a small mistake in my project name. I'll also check this in other places as well. Yeah, so I'll just fix that also quickly. Awesome. So I fixed that mistake quickly. And this also I'll save all the files, and we'll come back to health.co. Now, I know like this, I may have made many mistakes in the code. And what I'll do is, in the next video, I'll just install some plugins to help me clean up if there are any mistakes. All right. The reason why I'm not using plugins in this particular course, so I've used plugins, as you must have seen in the other courses, right? In this particular courses, I'm not using any plugins because on my Windows machine, there's WSL running. On that, there's Ubuntu 20.04, and on that, I'm running VS Code. All right. So with Hyper, I think it's called Hyper-V. I'm using Hyper-V basically. WSL is a functionality in Windows which helps you to run these different Ubuntu, and you don't want them to become very heavy, so that's why I don't install a lot of different plugins and extensions and all that. But I think I'll do that for this video, because otherwise there will be just too many issues that we won't be able to handle. So new handler takes in repository, which is of type, or you already know it's of type adapter.interface. So you'll just copy and paste this here. And what does it return? It returns handlers.interface. So we're basically creating a new handler. So it returns a handler. And we'll say repository. repository. Now with your get function, this is not a regular function. This is actually a method of the type handler. So we'll say h handler. So this is a struct method. In case you don't know what struct method are, you need to check them out. Struct method basically means that this function is a type of struct method. It's not just a regular function, right? So you can read more about them. I've also talked about them in a lot of videos, right? So in this video, I'm assuming that you know the basics of Golang. So we'll have http.request. So all these concepts are really important, right? Structs and struct methods and interfaces. In case you don't know them, I have many other projects which talk more about them. That's also there in all the basic Golang courses. You can do any course online, right? So in my courses, whenever I create something, I try to not talk about the basics a lot, because there's so many people who have videos for basics. I try and build products, right, and projects which you can actually use, which not many people talk about. So we'll have http status dot internal error. So we'll say status internal server error, which is, as you know, is 500. Inside that, you'll just pass these things, right? W, which is your response, your request, and you'll use the errors package, which we have put here, errors, and you'll use the function. In case you've not used errors package before, there's a function called new, where we're saying relational database not live. So it's creating a 500 error only, but it'll send you this kind of a text. And you return from this function. And if everything goes well, so this is when the health is not all right, then you do all this, right? You give an error. But if everything is well, right, you'll say http status dot status okay w comma r comma service okay. Now for your health package, you just want the get function to be there, as in you want people to check the health, and that's about it, right? But you don't want them to do anything with post, put, delete, and options, obviously. I'm not sure if you're understanding what I'm trying to say. So what I'll do is I'll actually create some handlers for product, and then everything will become much more easy to understand. So here in my product file, I'll create a package called product, and I'll import some things, and then again I'll create my handler, which will be of type struct, and here I'll have handlers.interface, very similar to what I've just done, and I'll have something else. I'll have a controller, which will be of type product.interface, and I'll have some rules, which will be of rules.interface. Don't worry about this as of now. Okay, you have seen this, but you've not seen these two things. Don't worry. We'll talk about them. But here we'll have some functions. We'll have func new handler, just like we did here. We add a new handler. And it's very similar, just accepts the same things. So repository adapter dot interface and returns handlers dot interface. In case you've forgotten what handlers dot interface are, these are basically inside your handlers folder. Inside your handler folder, the interface, which is this, right? Get, post, put, delete options. These are your this is your basically interface that we're talking about. And from here also you'll return and handler, right? And which will basically have your controller and your rules. So the controller will be of type product dot new controller, which we'll create as a function, and you'll pass the repository there, comma. For rules, you'll have rules product dot new rules, comma. And here you'll create multiple functions. So you'll say func get. It will accept some things, return some things. and then you'll have func get one, like, you know, just get one, not the whole thing, like not all the records. And then you'll have get all, so you'll have func get all. So in our get, this main function, we'll define get one and get all, like depending on what the person wants to access. And then we'll have func post, and we'll have func put, and delete and options. Sorry. Okay. So what I want to show you right now, before we go to the health.go and start filling up the insides of these functions, what I want to show you is that for the product, right, there are two things. One is for the health, we have an API for the get API, which checks the health of the entire project. Then we have all the APIs related to product, like get, add, delete, and all of those. So here we'll have something in the get, but we'll also have something in the post. So first I'll work on the post function. Okay. So firstly, as you know, like just we did with health here, our get, right, is a struct method. So similarly here also all of our functions will be struct methods, and that's what we're going to say here. We'll say h is a type of handler. Sorry, h. And post, you'll say w http dot response writer, and r, which is http dot request. Now there will be a function called get body and validate. So let me define it out here. Func right. So if you want to access, I'm not sure if you already know about struct methods, but if you want to access struct methods, this is how you do it. You say h dot get body and validate. So h is your handler, and all of these are different struct methods. And so if you want to access a struct method called get body and validate, this is how you're going to do it, because get body and validate is a struct method, and this is how you can access h dot. Accepts a couple of things, returns some things, and has a function definition. And I'll come to it later on, but right now I just want to show you something with the post API. So here you'll pass r and uuid dot nil, and you'll get your product body. So you take the request body and then you validate it, and then you get your product body here. And this is, so all that logic we're handling here. And once we do that, then you'll everything else will make more sense to you, as in how we're validating the body that we're getting in the request. But the main important part is that once it's validated as the right body for this product, then you get everything in this variable called product body, and now you can start working on it. But if there was an error, right, after calling that function, then you'll handle it with like this. You'll say http status dot status bad request. I'll just put some spaces here. And you'll also return from here, so you'll say return. But if everything went well, then you'd want to create something, right? So you'll say controller dot create product body and id comma error. So after you create something, obviously you get an ID back. So let's we'll handle it in our create function and controller, okay, which is firstly here. So we'll have to have a create function in our controller. But if there's an error, what we'll do is we'll say http status dot internal error, server error, and we'll pass w comma r comma error, and we would return from this place. But if everything went well, you'd say HTTP status dot status okay, w comma r comma map. You will send back a map with interfaces dot string. So whatever you've posted here, after you have created it, we'll have this function. Don't worry about this function right now. It will send us back an ID, and then we'll basically send the complete interface, like everything, as part of the response, saying that, okay, we have created this particular product in our database. So this is what this function is doing, right? Now, what I want to show you is that this is the type of function that you'll need in your post and your handler. That means you'll have some routes, then you'll have a handler function like this. And what you see here is that the handler function is essentially calling a function in your controller. It's just doing some validation thing, which is also happening in another function. And whatever it gets, it's just you calling a controller function to basically, it's basically calling a controller function, right? That's what the handlers is doing. So it's not doing a lot of work, the handlers. I would just wanted you to be mindful of that. So you have routes, not doing a lot, handlers not doing a lot, but just organizing information. Then controllers kind of doing a lot, right? And then you have your database level functions, which is basically talking to the database and actually performing all the CRUD operations at the database level. But having this kind of a structure, routes, handlers, controllers, and repositories makes everything so well organized that you know where exactly is the logic for which exact thing. So you can, you know where to look for errors, where to look for validations, where to look for changing of the information, where the response is coming from, and where the exact database functions are taking place. So it's like separation of concern, and you know where to look for which exact thing. All right. So now that you know that this is what the post method of product will look like, you would also understand that the put, delete, and options will also look like something like this. Whereas for health, we just want the get function to work, right? We don't want any other functions to work. So what you want to say is that if you try using any other methods like post, put, delete, options, we want to say basically that for the health routes, this is not allowed. This status is not allowed. And now, as you know, that function put, post, and all these are basically, essentially, they are struct methods and not just random functions. So we'll say star handler. And this is what I'm going to just copy and paste out here as well. Copying and pasting, according to me, is quite dangerous, because if you make a mistake in one place, you'll make it everywhere. So just make sure you copy and paste properly. I don't support it. I don't recommend or encourage it. But whatever. Sometimes you need to use shortcuts, and and people keep asking me a lot, why don't you copy and paste a lot, and why do you write everything from scratch? Is because I want to make sure that anybody who's new to Golang is following me. I want them to get very, very accustomed to the syntax, because what happens is that sooner or later you will end up in an interview which would expect you to write something from scratch, something that is like a critical program, but they would want you to write it from scratch without using any libraries. So implement like an algorithm in Golang, or create something but without using any libraries, or maybe they won't even give you a VS Code. If they'll give you access to libraries, they won't give you VS Code. They'll give you their own interview panel kind of a thing here, right? Which will be their own code editor. And you won't get all those extensions. So that'll be a big problem for you, right? It'll be an interview with the coding round. You don't get extensions. You don't get VS Code. You can get to use VS Code there. They want to basically understand how dependent are you on extensions and all the type of help, right? So serious companies with serious development requirements, they'll probably want to test you at a deeper level, and that's kind of where the milk from the water kind of separates, or the wheat from the chaff, right? They want the wheat. They want the best developers out there, and this is a very easy way to check for great developers, is that they don't rely extensively on extensions and plugins. Sorry, that was a very long lecture, but just want to tell you that this is why I don't support copy and pasting. This is why I don't support using a lot of extensions. This is why I support write everything from scratch, get used to the syntax very, 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 very deeply, like embedded in your brain very deeply, because when you are faced with a very difficult problem, like a difficult algorithmic problem that a company will give you, a serious development company will give you a very difficult algorithmic problem, you won't get VS Code. You will be on a call with them. So you will be under a lot of stress and pressure. They will try to put you under a lot of stress. They will check, how does this guy respond in pressure and stress. And in that kind of a scenario, you have to find a solution to that problem. So you don't want the syntax to be your limitation, because the problem itself is going to be very difficult, right? So you don't want the syntax to hold you back. This is why I recommend that stay an old school developer. All right, so HTTP. And by the way, I mentor a lot of developers, so I can tell you what's happening in the industry right now. And this is a big problem, and this is why many people don't get into the kind of roles that they want to, even when they have a very good resume and very good experience and they're very good developers. But this is something that kind of holds them back to actually reach their full potential. So you have status method not allowed, and w comma r, and here you'll again have input. You'll have w http dot, again response writer, r star http dot request. So I always recommend that whenever you're watching my videos, build along with me, build the entire product along with me, so that you get used to creating products just like me. And I don't think you'll find tutorials like this anywhere, because you basically are building the early stages of an actual product. So once you have like a complete structure in place like this, right, you can build any product you want. I mean, you'll get selected in any company by showing this kind of a project. So you have put, you have delete here. For delete, you'll have http status dot status method not allowed again, w comma r. And in options, again, you'll pass. So for delete, we have not passed w and http dot response writer, comma r star http dot request. And in options, you pass w http dot response writer, comma r star http dot request. And http status dot status no content, w comma r. So that was your complete health.go file. So this is what I want to show you, that post, put, delete options, for all of them you want to say status method not allowed. So when I somehow thought that if I showed you all these functions without actually showing you what's going to happen in another function, you'll probably get confused. You'll think, why are we just writing method not allowed in all of these functions? That's because for product we want to handle these functions, but for health routes we don't want to. We just want to handle the get method. So whenever in product also, if we find that this particular method that we don't want to handle, then we can just use method not allowed. So this kind of handles a lot of errors, right? A lot of permissioning also for the APIs. And I think we've done quite a bit in this video. Now, for get1 and get_all, both of these functions, how do you determine which function gets the control, right? So that will be determined in the get function. So firstly, this function is not a regular function. It's a struct method. So I'll say handler. And in get, I'll say w, comma r. And what to write in front of w, it's basically http dot response writer. And r is star http dot request. So since we're using the chai router or kai router, whatever you want to call it, I'm going to check for the URL params. So if it has id in the params, which means id not equal to empty string, then I'll use my get1 function. Else, I'll use my get_all function. That means if I'm not passing an ID, that means I'm expecting everything to be returned, all the records to be returned, so you call the get_all function. So if you're getting confused here, h dot, what does this mean? This basically, whenever you create struct methods, right, you can call struct methods with h dot. The struct being h, right? H is a struct, handler is a struct, and h is a type of handler. So that ways you can basically call all the other struct methods with h dot get one, h dot get all, like that. So whenever you see something like this, that means it's not a regular function, it's a struct method. Anyhow, so now we want to start working on our get one and get all function. They'll be very similar, but obviously a few changes will be there. So you have handler and get one, you have w comma r. For w, you'll say http dot response writer, and for r, you already know, you'll say http dot request. And here you'll say id comma error uuid dot parse. So we'll be using a UUID package as well. So here I'll say chi.url param. The bracket I'll send r comma id. So since we're using these packages, why don't we start importing them? I'll be using errors in a while, and most importantly, I'm using github.com/go chi/chi/chi. Okay, and I will be using the UUID package to create a unique ID. So I'll say Google/UUID, and others that I need is net/http and the time package that I'll need in a while. Right, the other things that I need are obviously handlers and all those things, tools and everything. So those are basically my internal files and packages, and I can call them anytime I need them. So coming back to your get one. So for get one, you basically need the ID, right? And if there's an error at this stage, you will say http status dot status bad request w comma r comma errors dot new id is not UUID valid, and you'll return from this function. Otherwise, you will call a function called list1, which is not here, but it's actually in your controllers that we'll create it very soon. You already know, right? I've told you in the previous videos, from routes to handlers to controllers to repository, that's how our flow is going. So that's why if we're in handlers right now, that means the sole job of the handler is to basically call a controller function. So you're saying h.controller.list1, and you're passing the ID because you want to fetch the record in your database for that particular ID. Let's say response comma error, and then we'll check if error not equal to nil. We'll say http status dot status internal server error w comma r comma error, and from here you'll return http status comma status okay w comma r comma response. So all that this function is doing, get one, is taking an ID and getting from the database just that one particular record. That is it, right? So it'll send WR in the response. For get all, and the decision for get one and get all is taken here in the get function. For get all, similar, quite similar. You have this as a struct method. So you'll say handler, and get all you'll say w comma r. W you'll say http dot response writer, and r you'll say http dot request, and here you'll say http dot controller dot list all response comma error, and here you'll handle error. So all that this function is doing, this is actually the main part here. This function is just calling a list all function. Here you were calling list one, here you're calling list all function in your controller. And then you're checking for error. That's it. So it'll say HTTP status dot status internal server error w comma r comma error. And from here you'll return. But if everything is all right, then you would want to say HTTP status dot status OK w comma r comma response. You want to send the response just like you did in the previous function. Exactly the same. So the get method is done. The new handler method is done. Get one, get all, post, all of them are done. You're left with about 3-4 more methods, right? So let's work on the put method, which is usually considered to be the most difficult, right? Because it has the most details. You have to take care of a lot more details. So for W, you have HTTP dot response error, and for R, HTTP dot request. And you'll check, you'll again use the UUID package to parse chi dot URL param r comma id and you'll get the ID from here. Otherwise, if there's an error, you'll handle the error. So for handling the error, you'll say HTTP status dot status bad request w comma r comma errors dot new ID is not UID valid, and you'll return from there. And here you'll have a function called, I'll call a function called get body and validate, which is this function, right? So whenever you're using post and whenever you're using put, you're getting some body from the request. So because obviously when you're posting, you need all the data for that product. When you're putting or when you're updating, you are also getting some data, which is the new data, going to be the new data for that same particular product, right? So whenever you're updating something, you get the ID and you get the new data for that particular ID, and that's what we want to update. So when we have received this new data from the request, we want to validate it, just like we did for the post method. And here you'll say product body comma error, and then as usual we'll handle the error. HTTP status dot status bad request w comma r comma error, and obviously if there was an error, you'll just return from this function. Otherwise, if everything is okay and you didn't have an error, that's when you do the most important thing, which is as you know, it's a handler, so it'll just call a function, a particular function in your controller, in your controller, sorry, from the handler. And what function is going to be? It's going to be a function called update. So, and what you send to it, you always do an update function. You send the ID and you send the product body, because we need to find that particular record from the database, and we also need to update it. So you need the ID to find that particular record from the database, and you need the new product body so that you can use that new data to update it. So here you're checking error not equal to nil, and you'll say HTTP status dot status internal server error w comma r comma error, and you'll return from here if there was an error at this stage. But if everything was all right, you'll say HTTP dot status no content w comma r. Okay. And now with the delete function and the options. With options, you're just sending no status, no content. So what I'll do is I'll just get over with this quickly. So options is again a struct method, accepts W and R, nothing changes there. HTTP dot response writer and HTTP dot request HTTP status dot status, no content, W comma R. So I'll be needing one more function here, and we'll talk about it. It's called set default values. So in this video itself, we'll have to tackle this function also, and I'll be needing this function. We'll talk about it in a while. So your options function is complete. Now delete function is also quite straightforward. Let's work on that. So before delete, since it's a struct method, you'll say handler, and after delete you'll say W comma R. W has HTTP dot response writer and R has HTTP dot request. Okay. To delete something from the database, what do you need? You need the ID, because with that ID you'll find the exact record and then you'll delete that particular record, right? So again, you have to do UUID.parse, and your JRouter is going to give you access to the parameters. And the parameter that we want access to is the ID, because we want the ID of that particular record. And we are capturing that in a variable called ID with capital I, capital D. If there's an error at this stage, what you're going to do is you're going to say HTTP status dot status bad request and W comma R comma errors dot new ID is not UUID valid, and you're going to return from here, and h dot controller dot remove ID. So as you know, that handlers are always responsible for calling a function in the controller. So that's why we're calling a function called remove in the controller. Now that you have seen all the functions of controllers that are being called here, we'll have a very easy time working with all the controller functions. So if error is equal to h dot controller remove, we'll handle the error itself out here itself, and we'll say HTTP status dot status internal server error comma R comma error, and return. If all goes well, we'll say HTTP status dot status no content W comma R. Perfect. Everything is great till here, right? All the functions are done except for these two functions, get body and validate. So to be able to work on this function, there's some things that you need to understand. Let me show it to you. So usually, as you know, what we do is we get the body in JSON. You know that by default Golang does not understand JSON, right? So we do a lot of unmarshalling, then we validate the data, then we marshal it and then send it to the database to store that. So this we do in, let's say, a post or a put request. This is the usual format, and this is what we've been doing. If you have been watching my videos, this is what I do usually, right? So this time we're trying a different approach, and we're trying a different approach because somebody had commented on one of my YouTube videos that they want to see how interfaces work, right? So how do you work with interfaces? Now with working with interfaces, this is how you basically go along. You have the body, then you convert it into struct, then you go from interface to model, and then at the end you validate, right? And directly at the end here, as you can see, you're getting the model level data, as in how DynamoDB is going to represent that model. And all of this heavy lifting, we don't have to do it. We'll just create some basic functions to do it, and it won't be very difficult. So this approach is kind of cleaner, but I've seen this being more widely used in the industry. This is cleaner. Obviously, it's a different way of working, and this is what we'll be doing right now, right? So going back, so I just wanted you to get a feel of what we're doing visually. And you already know, right? You already know that this function has been called in the put method and then the post method. I've called this function to work with the body that you get in the request. All right. So this validates this. Firstly, this does the equivalent of marshalling and marshalling, right? But in this case, which is like interface to model, that kind of work, right? And also using the struct, and also validates. So it takes us R takes ID, and which is HTTP dot request, and ID, which is UUID dot capital UUID. And here it will take something called as the entity product dot product. In our entities folder, we'll create this file. So for the time being, don't worry about it. But I'll write some code here which will help you understand what this is going to do in the first anyways. Like it's going to do something and you'll understand what it's going to do. And we'll also define this function in the entities folder. But for now, you just need to understand what it does, right? And it becomes really easy. So firstly, you get something called as the entity product dot product. And then you put this in a variable called product body. Okay, so stay with me for now. This is what's doing. But you want to convert the body that's coming in the request, right, as JSON. You want it to convert into like let's say a struct or interface kind of a thing, right? So what you'll do is you will call a function that does this, converts it into struct. How do you do it? You'll say convert IO reader to struct. You'll pass whatever you're getting in the request body, and you'll also pass this product body interface. And what we're going to call is this function basically is going to be defined in a file called rules. So this folder called rules is something that we have not worked on. This folder called entities we have not worked on, but we've already started using the functions that we'll be writing in those files, right? So when we actually write those files, we'll have more context as to what we're writing. And this you will get it into body comma error. Okay, let's handle the error now. So I'll return ampersand entity product dot product. It returns something like this, and errors dot new body is required. I'll just fix the spellings and everything. And if there was no error, then what you'll do is you'll do something to change that interface that you just received right now into a model. So how do you do that? You'll say interface to model, which is going to be a function which you will define in entity product. So this entity product, which is going to be entities here, is going to have this function that helps you to create from interface into model. Now, mind you, these functions are not going to be very complex and they'll do a lot of heavy lifting for us. This is a different approach. It will take a while for you to wrap your head around it if you've not done this approach, right? And this is a different approach. I don't usually do it, but many people want to know how to work with interfaces and how we can actually use interfaces in a program, in a project. And this is why we're doing it. You can go ahead and do the older way that I use, which is basically marshalling and marshalling. I think I've followed that in my complete serverless stack video where I've used DynamoDB. So if you want to, you can still use that, not a problem. This is just a different approach, just showing you how you can work with a different type of approach. Even if it confuses you, don't worry. You can always use the older approach, right? Don't get confused. There's just something different, something new. And I want you to be exposed to all these different type of approaches of work, so that if you join a company and they're using interfaces, or if they're using something else, you won't feel left out, right? So that's why in every single of my project, I do a different approach. I use the CHI, the chai router sometimes. I use Gingonic sometimes, and I'll be using so many more different frameworks in the future. So here you'll return entity product dot product. and you will say errors dot new error on converting body to model. And at the end, all you want to do is return the product, the parsed product, and you want to validate it, right? And the validate function will be in the rules folder. So as you can see, you have interface to model, and the last thing that you want to do is validate. That's what we've done. The last thing we've done is validate, and also you've returned the parsed product from this with this function. But there's one more thing that you want to do. You want to set default values for the parsed product and for the particular ID. So what are default values? Default values are, if you've worked with APIs, you probably know that all APIs have updated at, right? They have created at, things like created at. And that's basically what we want to update. So what I'm doing right now is a very clever thing, which is basically while getting the body as in for a function like a post function or a put function, I want to marshal the equivalent of that, basically convert it into interface and convert it into a model. I want to do all of that in a function. At the same time, I'm also validating that data, because the function is called and_validate. And also at the same time, I'm also setting the default values, right? So all three things in just one little function, which is this. So I'm doing all three things. So now I don't have to write the same thing again for put, the same thing again for post. I hope that makes sense. So here, what does it accept? It accepts, as you can see, the parsed product, which is called, we'll just call it product. And it's of type entity product dot product. As going to have ID, which will have UUID dot UUID. And this product that we have right now, right, that we're working with, for that you'll start setting up values like updated at is equal to time.now. So I've already imported the time package, I hope. Yeah, in this file I already have the time package. And I'm also going to check if ID equal to UUID dot nil. Then I'll say product dot ID. The UID dot new, will create the new ID for it, and product dot created at is equal to time dot now. So by now you already know that we're using this function, the get body and validate, for put and post, right? For both put and post, which is create and update. So for create, you will obviously have an ID. For update, you'll obviously have an ID because that particular record you want to update. But for create, you don't have an ID, right? You don't have the ID yet. So if the ID is nil, then you create a new ID for it and you created at for it. But if it's to be updated, then you don't have to have a field called created at. You don't have to update it, right? You just have to update the field which is updated at. I hope that makes sense. And else, right? When there is an ID, we'll say product dot ID equal to ID. And then you'll push that product for updation in the database. And that's your entire product.go file. Now there are a couple of things left, like importing all the other packages, the internally used packages that I'll be using. So what I'll do is I'll go here, I'll pick this up, and I'll put it here. And I want to start getting a couple of things, right? So one thing obviously I need is the adapter. I need a few more things. I need the controller slash product. So I'll say controllers slash product, because as you know, this is a handler, right? So we've called the controllers dot many functions we have called. So that's why I want to get the product controllers. And I want the entity product. So that's the whole thing that I've been using till now, entity product, right? I have not defined it yet. So if you've been confused about it, it's right. I mean, it's right to be confused because I've not defined it yet. And I'm going to say here internal slash entities slash product. And I'm going to call it entity product. Make sense? now I wanna get my handlers. So internal slash handlers, and you'll also get internal slash rules, which is this folder that, as you know, we have referred to, but we have not actually used. And specifically inside rules, you have product rules. So I'm going to get them also imported. Then inside our utils, we also have HTTP, which is our response. And I want to also import that. So I'll say utils slash HTTP. Cool. Whew. So here it is, the whole file. Product.go is also complete. There's also a couple of things. I am going to be calling this rules. So this I forgot. And here I'm going to be calling this rules product. And this I'll call HTTP status. Make sense? So whenever I'm saying HTTP status dot errors, this is what I'm referring to. So now this completes the entire picture. Okay. So I'm sure the whole the file makes sense to you. If it doesn't make sense to you, put it in the comments below. I'll try and help you out wherever you're facing any issues. But I've tried to go line by line. I've tried to explain every single thing. If you still have some issues or errors, do let me know. Obviously, before watching any of my videos, I highly recommend that you already know the basics of Golang, because I try not to spend too much time in basics. I try to get to the more advanced parts, so that there are some tutorials at least on YouTube where people are building stuff, right, and not just showing the basics again and again. All right, so I hope you're enjoying this. So we had done our routes. We have already done our routes and repository, all those different things, and adapters for the database. What we want to focus now is on controllers. We want to focus on controllers. So create a file in your controllers folder called product.go, and you want to call this, the package is going to be called product. You're going to have an import statement which will import a couple of things, and the first thing you want to create is controllers, which is of type struct. And you want to create an interface of type interface. Okay. Then you'll have a function which will basically create a new controller for you. It's going to return an interface. We'll soon understand why, right? Don't worry right now. And then I'll have some functions, right? So all the routes that I have, I'll have functions and then routes and handlers and then functions. These functions basically have a 1:1 relationship with the routes and with the handlers. Okay. So let me show it to you. Basically with the routes, you have these functions, right? Post, get, put, and all those different things. You basically will have functions for those routes. So the functions that we'll have will be list one, and we'll have a function for list all with 2 L's, obviously. And then we'll have a function for create and update, which are basically the fundamental blocks for a CRUD operation. You can have just list, which is view or read, right? In a CRUD, it's called read, the CRUD. And for reading, we have two different options. We can just get one entity, or we can get all the entities from the database. So, which is basically how that corresponds to your routes is get all or get by ID. Okay, so you have create, and you have a function called update. You'll have a function called remove, and that's about it actually. So list one is going to take the ID, because you need the ID, right? And in the API, it will be basically get by ID. So you'll list one, you'll have uid.uuid, and you'll return something from here. You'll return an entity. We have to still work on entities, don't worry. So entity will return entity, product. or it will return an error. So that's what a list one function does. Okay. And list all doesn't take anything. It doesn't require an ID as such to work on, because it's just basically going to return all of those, all of the data that exists in the database. But what it's going to return is our entities, which are of which is a slice of type product, and you'll also have an error out here. Now, one thing that we need to keep in mind is once we define this controller out here, the struct called controller, right? All of these, list one, list all, and all the other functions as well, are going to be struct methods. Struct methods are an important concept, and we have been using it for quite some time in all of our series. Do check it out in the Golang tour if you don't know what struct methods are. So basically what I'm going to say is that this is a struct method, and this is the way to say that. Right? These are methods for the struct called controller. And similarly with list all, list all is also the struct method. Okay. And similarly for my create, update, and remove, all of them are struct methods. So all I have to do is just copy and paste quickly. Okay. And to create, read, create, update, and delete, what you need to have is basically for creation, you're going to accept the complete entity, which is going to type product, and it's going to, after creating that entity, it's going to return the ID of that entity. It's saying that, hey, in our database, we have created that entity. This is the ID that you can now use for whatever purposes that you want to use, right? Just to give a proof that, okay, I have added something in the database. So that's why you need that UUID. So I'll say it's of type UUID, and otherwise, if it doesn't go through, as in something doesn't get added to the database, we're going to return the error, okay? So you may have noticed that I speak really fast. I just have this habit, okay, I think fast, so I speak fast. If you have a problem with that, do slow down the video to 0.5x, and then you'll be good, okay? You'll be good to go. So do check it out, do try making it 0.5x, and you'll start understanding what I'm saying. Because I see a lot of comments where people say that I speak too fast, and that's because when I learn coding, right, when I learn from other people, if I watch any video, I watch it at 2x usually. So I think if I speak fast, then it just saves you time. You don't have to 2x it or 1.5x it or whatever. Okay, so for update, you have ID and entity and star product ID. That's because when you're updating something, you need the ID, because you want to tell the database that this is the ID of the product that I want to update. But I also want to send the new entity, the new product, that, hey, this is the new product that you want to replace your existing product with. All right, so that's why I'm sending an entity also, which is of type product. I hope that makes sense. For removal, it's very simple. It's just the ID. You always pass just the ID, and we just return the error if there's any error. So for remove, you'll say ID UUID dot UUID. Okay, and that's about it. So now the whole thing revolves around the controller, right? Because as you saw, all of these are controller methods, and like the struct method, sorry. So everything revolves around the struct called controller that we have created right now. So what is it? The controller is it has basically repository, which is basically adapter.interface. Okay, so what does that mean now? If you go over to your repository and you go over to adapter and you go over to your interface, these are all the things that you have access to. You have access to health, find all, find one, create or update, and delete. Okay, so that's what your controller is basically now. Okay, and here you have your interface, and interface basically is going to be list one. Interface will make it very easy to interface with all our functions that we are defining out here. So, and this again, we have list all, create, and update, and remove. Okay. So we just define it here that the list one will need id.uuid dot UUID. Interface basically helps us to create a lot of abstraction. And you have entity product dot product comma error. List all doesn't require anything, but it does return entities, which, as you have already defined, is product dot product. Sorry for the wrong spelling. And comma error. There will be error out here. Create accepts an entity and returns either the ID of the new entity that has been added to the database, or it returns an error. And update, you've already seen it requires the UUID. And update, you already know it takes the ID and it takes the entity and returns error mostly. And remove just takes UUID.UUID and it returns the error. Perfect. So that's what your controller looks like. Okay. Now the new controller function is again going to return a controller, okay, mostly. So it will take in repository adapter.interface and it returns an interface, which is this interface. And what is it going to return? Like I said, controller repository and repository. So this helps you create the new controller. Now let's work on the list one function so that all of this that we've done right now will make sense to you. Okay. So firstly, that you will get in your list one is basically your ID, right? So first you'll create your entity. You'll say entity.id is equal to ID that you just received here. Because when you want to list something, you want to list that, basically get it from the database. So you're going to pass the ID and you'll have it in your entity.id, and then you'll have your c.repository. Now when I'm doing this, right, c.repository, because I can do that because I have access to the controller, which is the controller, because since it's a controller or a struct method, right? So I have access to that, so I can say a c.repository dot find one. And I can say entity dot get filter ID comma entity dot table name. Okay. So we are basically able to call this function called get filter ID, which will help us to get something from the database directly. And we're going to pass the table name, and in which table, like let's say products or users or whatever, right? So in our case, it's product. So in which table do you want to look for this particular ID or the data with this particular ID? Now we want to handle our error. So whatever we get from here is going to be either response or error. So if the error is not equal to nil, you want to return the entity and return the error. Otherwise, if all goes well, then you want to return product dot parse dynamo attribute to struct response dot item. Now, if you've worked with a project which has entities and this kind of a structure, right, the one that I'm showing you before, adapters and interfaces and all that, then you would easily understand what's going on here. But there's a high chance that you probably don't know, you've not worked with this kind of a pattern where we use entities. And that's completely fine. So I'm assuming you didn't understand this function, right? And you're not understanding what is get filtered by ID, even though it's just basically going to take this and going to call a database function somewhere and get the data, right? But you're not understanding how it's working with entity and what is entity here. and what is pass Dynamo at which to struct, right? So in the next video, what I'll do is, instead of building all these functions, I'll build the entities so that all of this will start making a lot more sense to you. Okay, so let's do that actually. So a lot of you would have understood this because you have seen this kind of a pattern before, but a lot of you do not. You probably know what's happening here because it's basically calling a database function somewhere and getting some data, right? List one by ID. But you don't know exactly how it's happening. So for that, what I'll do is I'll create the entities file in the next video, and you will understand a lot more, if you're seeing this pattern for the first time, which I'm not sure how many of you are actually. Okay. I hope you've watched the video 0. So there's a part 0 that I've created to just give you more context as to what we are doing with this series. In case you haven't checked it out, please check it out before you come to this part 11 of the series. So what I did was I created part 1 to 10, then I created part 0, which is ideally supposed to be before part 1, before you, started the series, and then you're supposed to be on part 11, which is this video. Okay, in case you haven't watched part 0, please watch it. So let's come back here. In part 0, I've explained to you what the function, what each of these components, these different components like handlers, repository, and controllers, all of these do, right? I've already explained it to you. And in part 10, I had said that we'll now work on entities. So what I'll do is I'll go ahead and I'll start creating entities. There's a file that I'll create called base.co. So in part 0, I showed you why there's something called as base, which is base are those things that will be like the base things, like let's say the ID and the created at and updated at, those timestamps and those things that we have in our product. And then we have something called as the product itself. So we'll have a folder called product, and we'll have a file called product.go. And since I'm assuming you have seen the part 0, you'll understand why I'm doing this, right? Where I have a base and I have product, and they're both related. And product consists of the base also. So first we'll work on our base.go file. So firstly, what I'll do is I'll name this package entities. And we'll have our import statement here. For import, I need my github.com/google/UUID to create my unique IDs, and I need the time package. You'll soon see why. It's I can tell you why, because you've already seen the part 0, right? So you know that we have to put timestamps like created at, updated at. So for those timestamps, we obviously need the time package. Anyhow, so firstly, what we'll do is we'll create the interface. Now there's a high chance you probably know how interfaces work. It's a basic Golang concept, but in case you don't know how interfaces work, please check out the Golang tour. Please check out some, watch some material on YouTube on interfaces. And I'll also be creating a complete video on interfaces, so that in case you have not been understanding interfaces, in my other videos and in this video, you'll understand interfaces really well, and you'll understand why we're using interfaces everywhere these days. Like in my other series, I'm using interfaces, so you'll understand why I use it. And in case you don't know, I'm assuming that 90% of you would already know this because it's like a Golang concept, right? And it's not just a Golang concept; it's also there in many other languages. So there's a high chance that you probably already know this, but in case you don't know, I'll be creating a lot of content around this, so don't worry. And also, there's already a lot of content on YouTube around it. So we are setting all these different things. This interface needs to have all these different properties, like table name, generate ID, set created at, updated at, get map. We'll have a map of string, we'll have interface, then you'll have get filter ID, map string, and interface. Okay, so we've created our interface. Now we have to create our structs. So one is the base that you already know about. And the base struct is going to consist of ID, just ID, and created at, updated at. Okay, And then you'll have some functions to basically set your created at, set your updated at, and set your ID. To help you do that, you'll have these functions that we've already defined in our interfaces, which are basically those methods, right? The generate ID and set ID, these will be methods. So these will be base methods. So base is, you first define a struct called base, and then you create these struct methods that we'll create right now. For example, generate ID is a struct method. For it to be a struct method, this is how you'll write. Right, this is a struct method, okay? And here you'll say ID, and we'll use a UUID package. There's a dot here. And you'll also tell Golang that in JSON, this is what it's going to look like. And in your time package, this is what it's going to look like. Yeah, so in your time package, you'll access time with capital T. And you're also writing how it's going to look like in JSON. Here it will look like updated at. In case you didn't know, I mean, obviously you know that, but I'm just repeating it again, that Golang cannot understand JSON natively, just like JavaScript. A lot of people transitioning from JavaScript to Golang get confused because they're so used to JSON being understood by JavaScript, but it's not the case with other languages. With Ruby and with languages like Golang and Python, you have to work on the data for the language itself to understand JSON, because any other language apart from JavaScript does not understand JSON natively. They have their own patterns and they have their own data structures. Anyhow, with that out of the way, let's create our methods. So what this method generate ID does is it just creates a new ID. And how does it create a new ID? It takes UUID package and it calls the function, the new function, to create the new ID. And for the base, which is B in this case, this is how you're setting the ID. Okay. Now we also want to create, similarly, we want to create methods for created at and updated at. So similarly, you'll set like this, b.created at is equal to time.now, which is the time that's right now. And similarly, we'll do the same for set updated at, which is b.updated at is equal to time.now. And I'll need one more function, which is to get time format. This returns a string to me. And here we'll set the time format, which could be anything. It could be, let's just give a random year like 2010 and 0102. This is a regular timestamp. If you don't want to write it on your own, you can get it off the internet. This is the regular timestamp that you get. So this is the kind of format that we want to follow for the time, right? For the timestamps. Now your base file is ready. You want to start working on your product file. So here we'll call it package product. We'll import a couple of things. The first thing that I want to import is encoding/JSON. Now, a few minutes back, I talked about how Golang does not understand JSON on its own. That's why you need to use encoding, the encoding package, and JSON, right? To be able to work with it. So it's called marshalling and unmarshalling that you have to use, and the encoding package helps you to do that. And we'll also need the errors package and the time package. And then we'll need a couple of more packages. We'll need the service DynamoDB package. So let me import that also, github.com /aws -sdk -go /service /DynamoDB. And you'll also need the github.com/google/uuid package. And I'll need some entities. I'll need these entities, basically the whole thing to, basically I want to, work with base. So I'll import that later on. But for now, what we'll do is we'll define a product struct. We'll define a struct called product. And it'll have, like I said, it'll have entities.base. This means that it'll have all of these different things. It'll have ID, created at, updated at. And it will have its own name. So, and this I had shown you using a diagram in the part 0 of the series. String, and here you'll tell it how does it look in JSON. It looks like this. It'll be name basically. So you created 2 structs, right? You created a struct called base. Now you created a struct called product. And so we want to create a couple of functions, starting with a function called interface to model. I've talked about this function in the part 0 video of the series. This function helps us to do a lot of marshalling and unmarshalling from JSON to a format that's understandable by Golang. It's going to accept data which is of type interface. That's why the function is called interface to model, and it returns the model itself, which in our case is product, which is a struct, right? So it's going to say instance, and which is basically your product, comma error, which is an error. And here we'll write some logic for marshalling and unmarshalling. Another function that I need is my getFilterID. This function we've already used, in case you forgot or haven't noticed. We already use this function here in our controllers. When we are using the find1 function, we are getting our getFilterID. Basically, we're trying to get our ID. So how do you get your ID? We'll have the function here that will define it. This returns a map, string, interface, and most importantly, this function is a struct method. Right? So when I write something like this, it just means that this is a struct product and this is a struct method for that product, or for that struct, right? This is the method for that struct. Then I'll have one more function called the table name, which it doesn't do much. It just returns the name of the table that I want to send data to in DynamoDB. In this case, it's simply products. So as you can see, we don't have to do these things, but we're doing it just to get a layer of, like it just makes the code cleaner, makes everything, provides abstraction in the code, and it's just a good design pattern. Just a good project structure. So we don't have to do any of this, but it's just, it's completely optional. We can do that, right? And now I have another function that I need later on, not as of now, but I'll still create it. It's going to be a struct method as well. It's going to take nothing. It's going to return a slice of bytes or an error. Doesn't do much. It just returns json.marshal product. Now you want to also create 2 more functions. So 2 more functions. I'll just open them up here. One function that I need is called getMap. And the other function that I need is called parse dynamo attribute struct. This was the function I was talking about that might confuse you guys. This is why I created the part 0 video at the first place. We had reached part 10, then I thought this is the function that will come and it will confuse you guys. So let me explain all of that to you in part 0 of that video. That's why I created part 0. So I've talked about this function there as well. And we'll create this function here. Basically, all the Dynamo attributes, parsing that into a struct. That's why we basically have this function. Okay, so what I'll do is I'll at least complete this interface to model function quickly as in. So I want to take a variable called bytes, and I want to take error, and I want to call json.marshal. So JSON, I have access to that from this library called encoding. I'm going to say json.marshal. I'm going to pass the data, which is basically the interface that I'm getting here. Then we'll just handle the error. We'll say if error not equal to nil, we'll return the instance, comma, error. And finally, you'll return the instance, comma, json.onMarshal bytes, comma, ampersand instance. All right, so we just left with these functions, and then our entities folder is also complete. A lot of the code in this project is complete. I think a couple of a few things here and there might be left, but that's about it. I think the tools is left probably, and that's about it. I mean, not much is left, right? So this is where I'd like to end this video, and we'll follow this up tomorrow, and we'll try and complete this video series quickly. If you have any comments, any issues, any problems, put them in the comment box below. I'm acknowledging the fact that there are some new things that we're doing in this series that you may not be comfortable with. It's completely okay to ask questions. We're doing a lot of things that may not be necessary. You might think it's not necessary to have a function to just get the time format. It's not necessary to have a function to just get the table name, which is products, right? But this is just a different type of a project structure and design pattern that we're following this time. Now, I won't talk about design patterns. I won't try and confuse you, because I know there are a lot of like people who are new to Golang who are trying to follow this. So I won't talk about design patterns and the different design patterns and how they work. I'm just getting your feet wet. I'm just showing you what this is. And then I'll create actual videos about design patterns from scratch, and why we have them, and which are the ones that are there, and which are the best ones, and how to use which design pattern. Right now, this is a design pattern, kind of a hybrid design pattern, but I won't try and confuse you. Just try and follow this project structure, get used to it, get used to the syntax, understand how things are going in this project, and then I'll take you to the next level, which is helping you to understand from design patterns. Okay. So I hope all of this is making sense. If it's not making sense, please put it in the comments below. I'm always there to help you out. I can have a call with you also if you want, right? Or connect with me on LinkedIn. I'm always there. So my description, like my link for connecting with me on LinkedIn, is always there in the description of all videos, almost all videos. I want to work on the controllers folder and the product controllers file, basically. And we'll be doing 4 functions in this video. List, all, create, update, and remove. These 4 functions we'll take care of in this video. So now, as you can see, all these functions are struct methods, right, of type controller struct. And we have defined the outline of these functions. So now it's time to start writing the functions. So firstly, I want to define a variable called entities, which is going to be of type product. And I'll create another variable called entity, which will be of type product. So entities is plural, and entity is singular, right? So plural in the sense you'll have a slice of all the products, whereas entity single will be just one particular product. And now, as you know, the way we do it is we create a filtering variable that helps us to filter, and we send that filter variable to the database to help us filter based on a particular condition. So let's create that filter. So the filter in this case is going to be expression.name. So basically the product name. Want to filter based on the product name, and not equal expression.value. So basically the product name should not be empty. There should be an empty string out here, right? And you want to create a condition also, so there'll be expression dot new builder dot with filter, and you'll pass the filter here in these brackets dot filter. So you're building the condition with which we'll filter out, right? So we'll use the filter that we've just created to build the condition, and we'll use the condition to actually run the program, run the query on the database. So at this stage itself, we might have an error. So I want to handle the error. So we'll say if error not equal to nil, return entities, comma, error. And then you want to use your repository to run the actual database level function, which is find all. And in your repository is where you'll find this function, repository, right? The spelling in my case is wrong. So I'll say find all, and then you write the condition from entity dot table name. And here you'll get response comma error. And here also you'll check for error. If error is not equal to nil, return entities error. Okay, so every single time, whenever we're writing something, any function, we are also handling the error at that point of time. Now we'll receive some. We expect to receive some response here, right? Whatever this our repository has a find all function, which is directly the function for DynamoDB to find something in DynamoDB, which is going to use a condition, and the condition that we just created here using filter, and the table name, the particular table name in which we want to run this query. So whatever we get back from this function, we get that in a variable called response, and response is something that we want to check if it's empty or not, because if it's empty, then we want to do something about it. So if response is not equal to nil, then we want to do a particular function, which is we'll run a for loop on the response. If it's empty, you can't really run a for loop on empty items, right? So because response has some items, we want to run a for loop on it. And I'm going to take a variable called entity, which I already have defined here. So I'll take that and I'll start capturing pass dynamo attribute to struct the value into this variable called entity, right? We've already talked about this function, pass dynamo attribute to struct. It basically converts everything that's stored in the DynamoDB into a particular struct that's understood by Golang. It's a very important function, and I've already talked about it in one of the previous videos, and we've already built this function. So in case you want to go and check it out, you can. Now you want to handle the error also, and you want to return entities from this function. And we have entities, just go to append whatever entities you've just found, just append entities with entity that you just found. All right. And at the end of this function, you want to return entities, comma, nil. Awesome. Now you have the create function. And what I want to do right now is I want to update the timestamp. So whenever I'm creating something, right, there's this timestamp that I created at, which usually you also do that in any type of database or any type of program. And if you've been following along with my videos, different videos, you've seen that I always store these kind of timestamps in the database. So here, when something is getting created, when this function is getting called in the controller's create, I want to update the timestamp that when was this item created. So you'll have time.now, which is the timestamp for right now, because right now is when the item is getting created. And you'll have a function called repository.create or update. And here you'll say entity.map, get map, entity.table. So you want to pass the entity, and you want to pass the table name for that entity, and you want to call the create or update function in your repository file. And that's all this does. It just creates a new entity in the database. Okay. And so once you create something in the database, you want to return the ID of that thing that's created. So you'll say entity.id, comma, error. Error is going to be small caps. Now you know that I always work on the update function in the end, because it might have some complexities. So that's why we'll work on the remove function before we work on the update function. So here you'll say entity comma error c dot list one and ID. So firstly, you want to list that item. In the sense, you want to find that item from the database, right? That's what we're calling list one with that particular ID. And if error is not equal to nil. So whenever we run a database related function, we always want to check the error because it can lead to errors right out there whenever we run a database level function. So you list one, and then you want to say c.repository. After you've listed that thing, you want to delete entity.get filter ID or entity.table. Now, if that item is getting deleted, you don't want to capture that in any variable. So that's why I'm keeping the blank variable here. Whenever we add something, we usually keep that in a variable. We capture that in a variable. But when you're deleting something, you don't really not want to do anything with that data when data is getting deleted. So that's why you use a blank character here. But you still might, so I told you whenever you run a database level function, you might have an error. So that's why to handle the error, you always want to have the error at least up there. And if there is an error, you want to return that error from this function. Now the only thing that's left is completing the update function, sorry. So how do you do that? So firstly, you want to list that item. So you'll say list one, and then you'll pass the ID of that data part, the data that's stored in the database. And here itself, you'll look for error. Now found, whenever you run this, right, whatever it returns is going to be captured in a variable called found. And here, if something goes wrong, we want to handle the error, and we want to basically return the error from this function. Now, whatever you found, is the ID is going to be ID. The name is going to be entity.name, and found. Just like you had created at for the create function, you want to have something called as updated at for the update function, because you have usually two timestamps for any data value, created at and updated at. Whenever it gets updated, you want to update this updated at value. Now I forgot a dot here, so it should be found dot updated at. Let's go to time dot, so small time dot now. Awesome. So you want to create, you want to call your repository package. You want to call create or update function, and you want to say found dot get map entity dot table name. Capture that in a blank variable. And you just want to return the error from this function. All right, so our controllers, product controllers file is at least complete, and that's quite a bit. You know, the whole file is complete now. And if you have reached this far, I hope you're learning quite a bit. You know the basics of interface and structs and struct methods, and now how we're working with DynamoDB. So thank you for watching. Do subscribe to this channel. In this video, I want to tackle the rules folder. So you have a folder called rules here, and in that folder, what you want to do, first let's close off all the other folders so that there's not much confusion, and open up the rules folder inside internal folder. In the rules folder, you want to create a folder called product. Inside that product folder, you want to create a file called product.go. Okay. Inside the rules folder, you also want to create another file called interface. Makes sense? So in the product folder, there's product.go file, and in the rules folder, there's interface.go file. So the interface.go file is going to be quite straightforward. It's going to basically be a part of the package rules, because as you know, in Golang, the way we keep it is we keep the folder name, which will be equal to the package name. So all the files in that folder will belong to that package. So this is package rules. You have a couple of things that you want to import. So firstly, I want to import IO package, and soon you'll come to know why I'm doing that. And the other package I want to import is github.com/aws/aws sdk /service/DynamoDB. Okay, and here I want to define an interface. The name is interface for the interface for these rules. And these rules will have 4 different functions that I can use through this interface, right? So the first function will be convert IO, which O is small, reader to struct. I've talked about this function, but in this video we're actually going to build that function. Takes data, which is IO dot reader. Takes a model, which is interface. Okay. And it returns body of type interface, comma, error, which is of type error. Then you have a function for getting some mock values, which again is interface, and with migrate returns an error. Just like get mock returns an interface, migrate returns an error, but it takes a connection to the DynamoDB dot DynamoDB, and we get access to this using this library. Lastly, we have the validate function. Just make sure you write the spelling correctly. It takes a model, which is of type interface, returns an error. Awesome. Now this will be of type package product because it's in the product folder. We're going to import a couple of things here, right? So we can either import them as we use them in the functions, or we can just quickly import them because I know which all I'll use here. So a few of them I can just get them quickly because I know I'll be using these. Obviously I need the errors package, I need the JSON for encoding decoding, I need my IO package, I need strings package, I need a time package, and definitely I'll need the AWS packages, AWS DynamoDB packages. I think I'll come back to that in a while. So firstly, I want to define a variable called rules, which is a struct, and then you have a function called new rules, returns the rules to you, which you've just defined that struct, and it's going to just return rules collection, which is empty struct. Now the functions that you'll have here, which will be basically these functions. So these functions, you want to be able to interact with these functions through this interface. That's why we created the interface for these rules functions. Now the functions are convert IO reader to struct. Second function is migrate. Then you have your get mock, and then you have your validate. All of the functions from your interface: get mock, migrate, and validate. But along with this, I'll have one more function called create table, which is part of my package products. Now, the convert IO reader to struct. It's a function, right? And it's a struct method of type rules. So it's not a regular function, it's a struct method. Takes data and it takes model. You already know that because we just defined the interface a while back. You already know it takes data and it takes an interface. And it returns an interface and returns an error. Awesome. Now you want to check if data that you're receiving here in this function is equal to nil. If it is equal to nil, then you will just return nil. Errors.new body is invalid. And you return model, comma, json.new decoder data dot decode model. So all that's happening out here is basically getting the IO data and then decoding it into a model. Now comes the migrate function, which is again the a struct method. So R star rules migrate, and to migrate the database you just need a connection to DynamoDB. So let's say DynamoDB dot DynamoDB error, and you're going to return R dot create the table with connection. So that means the create table function is being called here, and that's why we created this function here. It's not in the interfaces because the user is not calling it directly, but the migrate function is calling the create table function. I'll come to that in a minute, but let's create the get mock function first. Get mock function doesn't take anything but returns an interface. Okay, what does it return? The interface it's going to return is product. Base, we've already created the base file, right? It's going to have entities.base, and when you actually go to entities.base, you'll understand what I'm talking about. It has ID created at and updated at, these three things, and that's what you wanted to have here. So you'll have ID created at. Okay, it's already written automatically created at time.now for me, and updated at, which is again time.now, and ID is going to be uuid.new, comma. Awesome. Here you'll put a comma, say name uuid.new string. Awesome. Now you want to have validate functions. Func R rules validate model interface, and it returns an error. So you'll take a variable called product model, comma error, and product package or interface to model function and the model. And here we'll check for error. So we'll say if error is not equal to nil, we're going to return the error. Sorry. Not equal to nil. Then you want to return the error. Awesome. Okay, so it has a get mock function which kind of returns a product interface with some default values, right? Because it's a mock data, and it also returns a name here. So that means to have a product, you need to have some base values and a name, right? So name will be a unique string, and base will have a unique ID created at updated or just timestamps for now. The timestamps for now. Then you have a validate function, and the thing that this returns is validation dot validate struct. We'll create these functions. Validate struct, and here we'll pass product model, comma validation dot field ampersand product model dot id validation required. Sorry, validation dot required commas dot uuid v4 ampersand product model dot name comma validation dot required validation dot length 350. So in case you haven't figured it out yet, which is quite easy to understand, that we are taking the ID and we're saying that validation is required for the ID and it's of type UUID version 4, right? So these three things it's checking. And then it's checking for the name, product model is name, then validation is required, and validation length is 350. Okay, so that's all that's doing basically. So firstly, you change from interface to model. You need these functions, these helper functions, to change interface to model, or change, Dynamo, pass DynamoDB into struct, or to create IO reader to struct. All these helper functions are there just for us to be able to move between different data types, JSON to something that DynamoDB understands, to something which is struct, which Golang understands, right? Move it around between different these data types. And that's basically what we're doing, and we're also validating this. Now the function that's left here to make is the create table function, which is the last function. And this is something that I'll pick up in the next video. We aren't left with a lot. Our rules are almost done, and we just have to work with interfaces, and then all the code on this project is done, and then we just have to solve and fix errors, and then we have to just run the project and test it. Right? So I hope you're enjoying it. I hope you're learning a lot. This is not a beginner-friendly tutorial series, as you already probably have guessed by now, and I've already said that multiple times in this series. If you're a beginner Golang developer, you need to check out the JWT authentication tutorial series, the HRMS, the CRM, e-commerce. There's so many, and the different type of scrapers and Slack bots and Discord bots. More than 100 videos I have on Golang, right? So go check them out if you're a beginner developer. So we were done with quite a lot in this project. Till now, we've done quite a bit. So the only thing that's remaining is finishing the create table function in our rules product file. And then what we'll do is we'll fix all the things. And to save your time, I won't fix everything or the typos and the errors in front of you. I'll fix everything and I'll push it to GitHub, because it'll take me approximately 30 minutes to fix everything. So I don't want you to waste your time with me on that. And I'll fix everything in the background, and I'll push it to GitHub, and I'll put the GitHub link of this entire code, right? Everything debugged for you. You'll get everything on a platter. So everything will be debugged for you. I'll put it on GitHub. You just have to make a copy of that and just compare your code with this, and then everything will be fine. But what I will do is I'll show you how to run this code, right? So we'll run it together right now. So I'll take like a 30 minutes break in the video, and then I'll show you how to run this code. And that will be it for this series. That's how I've planned it for this video. So in this file, what's really missing actually is the packages that we need. So we'll be needing packages like the github.com/aws/aws SDK go /aws package. Okay. And we obviously need the DynamoDB package, so I'll get that also. .com/aws SDK go /service/DynamoDB. And I need a validation package out here, this one. So even though I've used it in my program already, I have not imported it. So validation is basically github.com/go also validation/v4. And then you have inside that same validation package, you also need one more package. You need github.com/go also validation/v4/is. And then you need the UUID package, because we've used it here. So to get the UUID package, we'll have to say github.com/google/UUID. And obviously we have our IO strings and time and errors and encoding JSON. But I need my entities and product. So what I'll do is I'll go to the internal product.go file and I'll just get this line from here so that I get access to the project name and everything. But here, instead of this, inside my internals, I need access to my entities and I need access to my entities product. So that's that. Now, what you want to do is you want to quickly finish up your create table function. Now we already know that this is a struct method and not just a simple function. Okay. So we'll say R rules and create table. This function takes a connection. Now everything that I'm doing in this function has been taken from the AWS DynamoDB library, the DynamoDB library that we're using here. And none of the code that I'll be writing here is my own code. I'm taking it from the DynamoDB documentation directly. So DynamoDB says that before you start using the tables directly, you have to ensure that the tables exist. So you'll have to create the tables yourself when you instantiate the connection with DynamoDB. I mean, you don't have to do that with MongoDB. You've already seen that in my other videos. So MongoDB automatically creates that table or that collection for you. But that's not the case with DynamoDB. So with DynamoDB, you'll have to create that using this create table function. So like I said, all of the code that I'll be writing here has been taken from the documentation directly. So you feel free to copy it from my code directly. You don't have to bother too much about it. I'll still explain the things to you. I'll still explain what's happening to you. But even if you don't understand it, it's okay because you'll be using the same code in all of your projects. So you just have to copy this function always and you'll be using it everywhere. So we'll take a variable called table and we'll say it's product.product. And then the DynamoDB package that the library that we want to access has this function that's the most important function here. It's called create table import function. For the input that you'll send to the table. And all of that can be captured in this variable called input. And like I said, this is the part where we are now referring to the documentation, which is attribute definitions. This is saying DynamoDB attribute definition, attribute name. Attribute name you'll get from your AWS package. So you'll say AWS dot string ID and attribute type. So you're telling DynamoDB that, hey, this table will have ID and it will be of type string. So this is the type string. And you'll put a comma here, put a comma here. Actually, there's one more bracket. Supposed to be one more bracket here. So we'll put a comma here, comma here. So this was the bracket for the attribute definition. Now at the same level of the attribute definition, you want to have something called as the key schema. So you'll say, and mind you, they're all inside this create table input bracket. So you'll say key schema. Again, you'll refer the same slice, which will have pointers to DynamoDB.schema element, key schema element. And here again, you'll create those two brackets, put a comma here, And here what you're saying is, again, the attribute name is aws.string underscore ID, and then you're saying key type aws.string hash. Then you have to go ahead and define, again, this is the requirement from DynamoDB. You have to define something called as the provisioned throughput. Again, you'll refer the DynamoDB library and you'll get a function called provisioned throughput. It has two variables, read capacity units and write capacity units. This is an integer of size 10 and this again is an integer. Sorry, with value 10 I meant. And then the last thing that you'll define is table name, which again string, and you'll use the table to get access to the table name. Now after this bracket, which I'll just format a little bit properly, after this bracket you want to define, you want to start a connection to the create table, and you'll send all this as input. So we'll say connection.createTable, and you'll capture that in a variable called response, or you'll handle the error. So to handle the error, what you'll do is you'll say if error is not equal to nil, and the strings contains error, then the table is already there. So you're trying to create the table, but it's already there. So there was no need to instantiate this. And you'll return nil. Whereas if the response is not equal to nil, and the string contains response.goString, then you'll say that I'm creating the table. So you'll say table status is, you'll have to put a little bit of escape characters here, creating. And you'll say time. So in this if statement, you'll say time.sleep for 3 seconds. And you'll create table with a connection. Just a connection, no need to pass the table. And you'll handle the errors. So if error is not equal to nil, you'll say return errors, and at the end, return errors. So that was it. You can see that there are two issues in this file, two errors it's showing me. But I'm sure there are just so many more, right? I know that there are many more errors. So what I'll do is I'll take like a 30-40 minute break and I'll fix all the errors. I'll push everything to GitHub, give you the link, and then we'll test this program together. What do you think? All right, so I'll see you in, like for you it'll be just 1 second, but for me it'll be like 40 minutes space. So I'll see you in 2 minutes. So I'm back and I have fixed the entire project. I'll be putting it on GitHub shortly, but I just wanted to show you how to run this program. So this is our folder that we had created, and it has the CMD folder, right? So you want to go inside the CMD folder. You want to go inside the app, and this is where you get the main.go file. And you want to say go run main.go. And it'll take a while to start off the service for you. And see, this is what we expected. We wanted it to say table found, and all these tables have been found. It's running on port 8080. Now, this is my Postman. And Postman, we have 6 different routes to test whatever we've done till now. So in the health check, which is the first route, what we've done is I've said localhost 8080 and /health. So you send, and you'll see that the status is 200 and the result is service. Okay, that means it's working. Now, it comes time of post. So for the post request, what you'll do is you'll say http localhost 8080 and /product. And here you can put any product. So let's say you put a product called wafers, and you create the product. So it says 200 and it gives you the ID of the product. And the best way to check if all the products are there is to say get all, which is basically a get request on http localhost /product, and you'll send, and you'll get all the products that I've created till now, including the one with the wafers. And if we want this particular product to be shown to us, so we'll take this ID and we'll go to get by ID, and we'll put it here, we'll put the ID here, and we'll say get by ID. Now to update the product, what you'll do is you'll go and put the ID there, and I'm going to call it, let's say something like chocolate. And it says 204 no content because we're not returning anything. We're not saying anything that this has been updated. But if you go and check the get all, you'll see that basically that there's a chocolate product here now. All right. And for the delete, it works in a very similar way. You open that and you take the same ID, and when you paste it here, now just a pointer, for the update you have to use the put method, for the delete you have to use the delete method, and when you send it, it again says 204 no content, just like the update method, but the data has been deleted for sure. So you go here and you see that the one with the wafer is not there. It has been deleted now. So basically this is what I want to show you, these 6 different what do you call it, that's the complete CRUD, basically 6 different APIs working perfectly fine with DynamoDB. It's a bulletproof CRUD system. This project has taken quite a long time. It's a lot of code, and this is why this is why I kind of broke it down for you. I explained to you every function, and this is for experienced developers only. So this is why I didn't explain every single line, but I did break down the functions for you. So you know the file structure, you know the project structure, you know what each function is doing, you know each file, what each file is doing, and you know how the whole project structure. But each line, sometimes I was not explaining it to you, but I'm very sure if you're an experienced developer, you have understood the entire project, and you've at least you know how to bring all these things together and build a project like this. And the best benefit is that you get this project on my GitHub. You just copy and use it. You just change the routes, change the CRUD functionality, and you're good to go. You have great project structure to use in all your future projects, right? And I am using this for a product of mine, a smaller product that I've built previously for a client. I use this exact structure, so I can tell you that it'll scale really well, because you can work with 5-6 team members as well. It can handle at least for that particular client that I'm talking about, it's handling more than 6,000 users, and concurrently about 500 to 600 active users it's handling. So I can tell you that it's a very, very stable project structure, and you won't face any problem till about 10,000 users. I can tell you won't face any problems with this. So this was it from my end, and thanks a lot for watching, and do subscribe to the channel if you haven't already. But I think you would have subscribed. That's why you watched this whole entire series. Thank you for watching, and I'll see you in the next video.